Welcome to the CompTIA A Plus certification course, your gateway into the world of IT support and troubleshooting. In this course, I will walk you through all the key topics you need to know for the latest CompTIA A Plus exam based on CompTIA's newest exam objectives. This course is beginner friendly but packed with essential skills you will need in real world IT roles. To make learning easier and more engaging, I have included clear visuals, diagrams, and step by step breakthroughs throughout the course, helping you understand complex concepts quickly and confidently. By the end, you will be ready to pass the exam and take your first step towards a successful career in IT. Hi everyone and welcome to the CompTIA A Plus Core 1 course. So this course is designed as per the latest and updated CompTIA Core 1 certification exam, that is 1201. And the exam objective of this course aligns with the official exam objective of the CompTIA. And Core 1 basically consists of these 5 domains. Domain 1 is mobile devices. Number 2 is networking. Domain 3 is hardware. Number 4 is virtualization and cloud computing. And domain 5 is hardware and network troubleshooting. And these are the percentage and weightage of each domain. So today we will start with the domain 1, mobile devices. So this domain is pretty basic and simple, and let's get started. So the first topic is mobile devices connectivity options. So mobile devices basically connect using both wired and wireless methods. So the wired methods include the USB, Lightning connector, USB-C, etc., while the wireless method may include the Wi-Fi, Bluetooth, infrared, etc. And the connection type basically affect the speed of the connectivity, compatibility, and the purpose for which this connection is required. So for example, the wired connection, they are pretty fast as compared to the wireless connection. And again, inside the wireless, some are fast and some are slow, such as the Wi-Fi is the fastest of all, while the Bluetooth and the infrared, they are slower connection types. And in the wired connection, some ports that are used by mobile devices, they are proprietary, such as this Apple Lightning connector. So this is proprietary connector from Apple, while others are universal, such as this USB-C. It is not proprietary, it is used by all vendors. So now coming over to wired connection, its types and uses, and the first one is the USB-C. So this is the most popular connection nowadays, and this is basically replacing all the other connections such as the Apple Lightning connector, the older USB, micro USB, and mini USB. So this connection type is reversible. Reversible means that you can plug this inside the port in either way, in this direction, or you can also reverse it and connect it upside down. So this means it is reversible, and it is fast for both charging as well as data transfer. And it is basically used in almost all of the modern Android devices as well as the laptops. Second one is the micro USB. This is basically the micro USB connector. So this was used in older Android devices, and this is fragile, and this one is non-reversible. As you can see, it has a flat surface at the bottom, while it has a little curved surface on the upside. So this is not reversible. Both the upside and the bottom, they are not the same. So this can be connected to the port only one way. Third one is the mini USB. So this is a very rare port. It is used in few devices such as the early cameras and MP3 players. And the last one is the Lightning connector. So this is Apple proprietary connector used inside the Apple devices such as Apple iPhones and the Apple MacBooks as well as iPads. So this is again, this is also reversible like USB-C, but again, this is not universal. It is only used by Apple devices. So if you people follow the news and the tech, this is also replaced by the USB-C. So the latest iPhones has the USB-C instead of Lightning connector, and this was not done by Apple voluntarily. Rather, Apple were forced through rules and regulations, specifically by the European Union. So now coming over to wireless short range connections. And the first one is the NFC, that is near field communication. So the NFC is basically very short range. It works at the range of only few centimeters, such as you can see this device, mobile device, and this payment system. They are very close to each other, almost touching each other, and it is used for contactless payments. So traditionally, we used to swipe a card or insert a card inside the payment system. While this NFC is basically contactless, you don't need to swipe or insert a card inside the payment system. It is wireless and contactless, such as the Apple Pay. So this NFC basically enables quick pairing or transfer of payment, etc. Next one is the Bluetooth. So Bluetooth is medium range. It has greater range as compared to NFC, but less as compared to other wireless connections such as Wi-Fi. And its range is maximum up to 10 meters. So it pairs with devices like keyboard, headphones, wearable, as well as smartphones also pair with each other through Bluetooth. And basically, this Bluetooth standard supports voice communication, audio transfer, or audio play, such as music, as well as data transfer, such as file transfer. Next one is the tethering and hotspots. So these are very related but different concepts. First one is the tethering. So tethering basically shares phone internet to one device using the USB or Bluetooth. So what does this mean? This means that let's suppose you have cellular internet such as 4G on this mobile device and you want to share this with this tablet. So you can do this through tethering using its Bluetooth connection, or you can also do it through wired USB connection. And the distinction between the hotspot and tethering is that tethering is used to share the connection with only one device. So this distinction is need to be remembered. So the hotspot, on the other hand, basically turns mobile phone into mini Wi-Fi router. So in the same way, if you have cellular internet and you want to configure this mobile device into a hotspot, then this device can share its internet with through hotspot with multiple devices. So now many devices such as laptop, tablet, and other smartphone can use this device internet connection. And hotspot is basically shared over Wi-Fi. So tethering basically uses USB or Bluetooth or even Wi-Fi as a connection method, while hotspot uses only Wi-Fi. So this is the one distinction, and the other distinction is that the hotspot shares internet with multiple devices, while the tethering basically shares internet with only one device. So this is a comparison table between wired and wireless connection types. So if we take the feature of speed, then the wired connections such as USB and Lightning, they are basically faster, while the wireless connections such as Bluetooth, NFC, these are slower. Except Wi-Fi is faster, almost at par with the wired connection. Convenience, so the wired, you need basically a cable, a compatible cable. So if you have Apple device, you will need a Lightning cable. On the other hand, the wireless connection method, it is more flexible. You don't need any cable. And the use case for wired is that it is used for charging as well as data transfer, while the wireless method is basically used for internet connectivity payments such as the NFC as we studied, as well as the music and audio playing. Next topic is the mobile device accessories, and our first accessory is the stylus. So then stylus have two types. First one is the active stylus. So the active one basically requires battery and or power to function. An example of active stylus are basically Apple Pencil that is used with Apple iPads and Samsung S Pen. And this active stylus is basically pressure sensitive for precise input. The second stylus type is the passive stylus. So this one does not need any power and it uses capacitive touch. So this stylus that I am using right now, this is basically a capacitive, or you can say passive stylus, because it does not need any battery or power to work. So this one, the passive stylus, basically works on any touch screen. And the use cases of stylus are note taking, such as here I am taking note and delivering this presentation. Digital art, you can also use stylus. It can be used by artists to do art, digital art, and precise selection. So here I can select precisely anything. So this one is basically for the active stylus, where you can select any part of the image through this stylus. Next mobile device accessory are the headphones and audio. So the headphone basically combines the features, headset basically combine the features of both the headphones as well as microphone. So the headset basically here, this one does not have, but the headset basically has a microphone as well. So you can use it both to listen to audio as well as use its microphone as an input device as well. So it can be wired, for which it uses 3.5 mm jack or USB-C port, or it can be wireless as well, for which it uses the Bluetooth connectivity. And the headset are basically used for calls, meetings, as well as it is also used by the gamers. Next accessory is the speakers, such as this portable speaker. So the connection type for speakers include Bluetooth. So this one will be Bluetooth enabled. It is most common method. Wi-Fi is also used inside speaker for connectivity, but it is for higher end models and expensive model. And another connectivity type which is wired is the 3.5 mm port. Power sources for speaker include the rechargeable battery. So these the portable speakers like this one, they use rechargeable battery, as well as they can also be wired powered, such as USB powered. And their specifications include that the higher end ones are water resistant and they have specific IP ratings such as IP68, and they have the stereo pairing capability. Next mobile device accessory is the webcam. So these are such as this one, basically external webcam, and they are used for better video quality. So the modern webcam are basically built in inside your devices such as your smartphone as well as your laptop. Traditionally, they were external and they were connected to the laptop or your PC through USB or wirelessly. And these are basically used for remote work by employees, for video calls such as Zoom calls, and for live streaming by the gamers or streamers. Next device type is the docking stations. So docking stations are basically used to turn your laptop into basically a desktop workstation, and it gives you a single connection convenience. So this is an example of a docking station. So you place the laptop over here, and then it gives you a type of desktop workstation connectivity. It gives you extra ports as well as other features. So it features include multiple video ports such as HDMI and DP display port. It also gives you other connectivity ports such as Ethernet for internet, for network connectivity, USB ports, as well as audio jacks. And it also often includes the charging as well. So for compatibility, it uses Thunderbolt and the modern USB-C port, and it was proprietary in the older laptops. Another related uh, concept is the port replicator, such as this one. So this basically expands the number of types of available ports on a mobile device. So let's suppose if your mobile device, such as your smartphone or your laptop, does not have an Ethernet port, you can connect this type of port replicator. It will give you Ethernet port as well as other ports such as USB, audio jack, DP ports, etc. So it is typically connected via the USB-C to the mobile device, and it offers a variety of ports such as USB-A, USB-C, HDMI, Ethernet, audio jack, etc., such as shown over here. So port replicator is useful for connecting multiple accessories simultaneously when a docking station is not needed. So if you are not using the docking station, then you can use port replicator and it will also give you multiple connectivity options. So now some mobile connectivity options, and the first one is the trackpad. So these trackpads are basically external touch sensitive surfaces for cursor controls such as this one. And this is similar to the laptop trackpad, but this is external. Laptop has basically built-in trackpads, while this one is external, and it is basically connected through USB or wirelessly through Bluetooth to the mobile device. Next one is the drawing pad, such as this one, and I'm also using this particular drawing pad right now to draw these different uh, connectivity options and to deliver this presentation. It is also very useful for online teaching as well as for digital arts and other purposes as well. So this is pressure sensitive surface for digital art and graphic design. And this one is usually connected via USB. So mine is also connected through USB port. And the last one is the track point, which is this one. So it is a small joystick-like pointer, and it is commonly built in the Lenovo laptops. So our next topic is the given a scenario, configure basic mobile device network connectivity and provide application support. So our first topic is the cellular network types, and our first cellular network type is the 3G. So this is basically a legacy and old standard, and it has a 2 Mbps of maximum speed, and it is almost phased out. It is replaced by the most modern and newer versions such as 4G and 5G. Next is the 4G LTE. So this is basically the current standard, and it has a higher speed of 100 Mbps, typical, maybe higher. And the latest one is basically the 5G. So this is the newest, ultra fast and low latency cellular connection type, but it has again limited coverage because it is being deployed and installed in place of these 3G as well as 4G. So for application support, higher network generation such as 4G, 5G basically provides a better experience for data intensive application and usages such as video streaming and online gaming. So you cannot use the modern heavy games with the 3G. For this you need the latest 5G connectivity for seamless experience. Next is the hotspot configuration. So we studied the hotspot, that it turns your mobile device into a mini Wi-Fi router so that you can share your internet connectivity with other mobile devices. So how do you configure it? So as I said, it shares mobile data connection with other devices via Wi-Fi, and it can be configured as following. Typically, you go to the setting, then network and internet, and there you click on the hotspot and tethering. Then you, inside the hotspot, you configure the SSID, you give the name to your connection, and then you enable the security. You can select either WPA2 or WPA3, or they both are available in this format, and you configure a password for this connection. You can also set data limits because this is very data intensive usage. Multiple devices will be using your cellular data. So you can cap the data limits, such as stop the connection when data usage reaches to 2 GB. And after that, you can enable the auto shut off feature. Next is the Wi-Fi connectivity. So to join the Wi-Fi network, you basically click on the SSID of a Wi-Fi network, and you need the password as well. So in the Wi-Fi connectivity, each mobile device basically has the auto connect feature, where once you join an SSID or a Wi-Fi network, you can enable the auto connect, so that in future, whenever you are in the range of that network, your mobile device will auto connect to that network. You can also forget a network. From the auto connect feature, you can forget a network, and then when you connect on that, want to connect to that network, you will have to enter the password again. Or you can also manually set up the Wi-Fi connectivity. So if you want to disable all the wireless connectivity of your smartphone, you can use the airplane mode, and then all the radio connectivity, including Bluetooth, Wi-Fi, as well as cellular connectivity, will be disabled. Next topic is the SIM card as well as eSIM. So SIM stands for Subscriber Identity Module. eSIM is basically embedded SIM. So this is physical, and this one is software-based subscriber identity module, and this is basically embedded inside your smartphone. So first is the SIM card. You all people must have seen the SIM card. It is a physical chip like this. So it is a physical card that stores your subscriber information and authenticates your device on the mobile network. On the other hand, the eSIM, it is basically a digital SIM card that is built in inside your device, and it can be provisioned remotely by your carrier. So you don't have to insert any physical card inside your smartphone. It is built in and it can be enabled and provisioned by your carrier remotely. Next is the Bluetooth connectivity. So Bluetooth is basically used for short range wireless connectivity to connect with other devices. And it is also used for accessories, mobile accessories such as headphones, speakers. It is also used for data transfer such as file transfer and many more uh, applications. So it requires pairing between devices for secure connection. So you cannot randomly connect to every other mobile devices. For the first time, you need to pair with that device. Enabling Bluetooth device, so it is also pretty straightforward. You go to the device setting, then go to the Bluetooth, and then toggle on the Bluetooth. Then you tap on pair new device to start searching or discovery. And you should make sure that the other device is also in the discovery mode or in the pairing mode so that you can connect with it. So the pairing process is pretty straightforward. So you scan for the devices, then you are presented with multiple devices. So you select your target device, and basically you verify match keys, or you enter basically match keys on each device, and then the connection is authorized and you can use the connectivity between the two devices. Bluetooth troubleshooting. So basic troubleshooting features of all devices, not only Bluetooth, that you turn on and turn off the feature or the device. You can delete the old pairings and create new ones. And the distance should be within the 10-meter range. And since Bluetooth is using this frequency, so you should avoid interference with other uh, connectivity or other wireless connection that are using the same frequency. So you also need to enter the pin code. So when you are pairing with the devices, you will need to enter the pin code. So some devices auto pair, other ask for a pin code for more security. And the default pins for the most devices are basically 0000 or 1234. So you need to enter the same pin on both the devices. So our next topic is the mobile location services. So mobile locations are basically used for different applications that need device locations, such as maps. So as I said, it is used in maps, weather applications, ride sharing applications such as Uber, and tracking as well. So it can be the mobile location feature or service can be enabled and disabled in the device settings. Another mobile device location service is the GPS. So GPS basically uses satellites to determine the precise location of the mobile device. So since it uses satellites, it works best in the clear sky and outdoor, and it is built into the most modern smartphones and tablets. Next mobile location service is the cellular location services. So it uses information from nearby cellular towers, such as this one, to estimate the device location. So the cellular location service is basically less accurate as compared to GPS since it relies on the general location of this cellular tower. So if you are 200 meters away from this tower, it means your location will have a range of 200 meters, accuracy range of 200 meters, and it can provide a location estimate indoor or when GPS signals are weak or unavailable. So this cellular location services can also be used indoor because mobile signals are available indoor as well as outdoor, and it can be used as alternative to GPS when GPS is not available or when you are indoor. So it is often used as a supplementary method with GPS for faster location acquisition. And since it is supplementary to, it is used as supplementary to GPS in applications such as AGPS, that stands for Assisted GPS. So the AGPS basically uses the cellular location service. Next is the hybrid location services, which basically uses all the location services, including the GPS, cellular, as well as Wi-Fi. And this is basically used by Google. Google basically uses all these services to track the location for its different applications, such as Google Maps. And it is also used by Apple location services. So the hybrid location services has multiple benefits such as faster lock-on because it uses multiple services. So the exact location is found faster, and it will also give accurate position indoor because it uses Wi-Fi as well as cellular service, and it has the feature of smart switching between different methods. Let's suppose you are using GPS outside and you suddenly came indoor, then your service will be shifted from GPS to cellular or Wi-Fi. Our next topic is very important, which is mobile device management or MDM. So MDM or mobile device management is basically used for centralized control or mobile devices inside an organization. And it is used to set up, monitor, and secure devices remotely. So first you set up your mobile devices inside this MDM application, and after that you can monitor the devices, and you can also apply security policies to the devices remotely. So this feature is used for both company-owned devices as well as for personal devices, which are used by employees as per BYOD, that is bring your own device policy. And key features of the MDM includes that it has the features of device enrollment. So the first step is to enter or set up a mobile device inside this application. You basically enroll the device inside MDM. Next, then it has multiple configuration features where you can configure different aspects of the mobile device. You can enforce different security policies such as password complexity, screen lock, etc. And application distribution means that you can also check on these devices to use or ban specific application from those mobile devices, such as you can disable the installation of, let's suppose, Facebook application on these company owned mobile devices through this MDM. So this is basically a comparison between the company owned as well as the BYOD mobile devices. So the ownership feature for the corporate devices and BYOD is that the corporate devices, they are basically owned by the company or the organization, while the BYD, that is bring your own device, they are basically employed owned devices. When we look at the control level, so the uh, corporate devices, they are basically fully managed through MDM. They have the full management of these devices. While in the BYOD, it has limited containerization. What does this mean? This means that the mobile devices is basically divided into two containers. One is the personal to the employee, while the next container is specific to the organization, where the organization specific applications and features are used and secured. Use case is that the corporate devices are basically used for field workforce, while the BYOD devices are used by the external consultants as well as the executives. So through MDM or mobile device management, basically the main important purpose of it is the policy enforcement, and the policy enforcement includes the password complexity requirements. So this can be enforced through the MDM. Let's suppose an organization may require that the password must be 12 characters long. It must have capital, small, and numbers as well as special characters. So this policy can be enforced through the MDM. It can also enforce the policy of automatic lock. Let's suppose after a few seconds or few minutes of idle. And this another important feature is the remote wipe capability. Let's suppose if the device is stolen or due to any other reason, the mobile device can be formatted or wiped remotely through this MDM policy enforcement feature. Another is, as I already said, the application blacklist and whitelist. So you can blacklist some application and whitelist other to be used on that mobile device through MDM policy enforcement. Our next topic is the mobile device synchronization. So it is basically the process of ensuring data consistency across multiple devices such as phone, tablet, and computer. So a single employee or a single person maybe uses multiple devices, such as he may have a phone, a tablet, as well as a computer. So the synchronization basically helps synchronizing all the configuration and data changes across all these devices. So this feature basically allows users to access the same information from any devices because information is synchronized across all devices, and this synchronization can be either done wirelessly or through a wired connection. So the synchronization features include syncing the calendar. So this ensures that appointments and events are consistent across all devices. So when you configure an appointment on one device, such as mobile device, it will also be synchronized inside your laptop and PC. So it is often used in cloud-based services such as Google Calendar and iCloud, and it allows for shared calendar and meeting invitations inside an organization. Another feature is the data caps, recognizing the data caps. So synchronization can consume significant data, especially when used over cellular networks. So that's why you should be aware of your mobile data plans limit to avoid overage charges. So you should consider using Wi-Fi for large sync operation. Another synchronization feature is the contact synchronization, which is to synchronize your contacts. So this keeps contacts information such as name, mobile numbers, and email addresses consistent across all your devices. So it is often linked to email account or cloud services so that your contacts are basically synchronized to your cloud or to your email account. So it simplifies communication regardless of the device use. So what does this mean? This means that let's suppose you are using smartphone and you configured a new contact or added a new contact on your device. So this will be automatically synchronized with your other devices and inside your cloud service as well. Another synchronization feature can be used for the email synchronization, such as business application synchronization for email. So this keeps email messages, folders, and setting consistent across all devices, and it is essential for staying connected and productive. And this feature is often used. This feature often uses protocols like IMAP or Exchange. So these are basically email protocol that can be used or that uses the synchronization feature. Next is the business application synchronization, that is cloud storage. So this feature keeps files and documents synchronized across devices and with the cloud. So it enables access to important files from anywhere. So you are not bound to a single device. You can use your application from anywhere, anytime, using any device, because all your configuration is synced across cloud all the time. So services like Google Drive, Dropbox, or OneDrive use these synchronization feature. Are these are the cloud storage services that can be used for synchronization of business applications. So that's all for domain one. This domain was pretty basic and straightforward. That's why I went through it a little bit fast. Next one is the networking, which is a little bit complex. So I will make sure that you understand each concept. So please subscribe, like the video, and stay tuned for the next domain. To our domain 2, that is networking, of our CompTIA A Plus course. So this is my favorite domain, as I myself is network professional having about 15 years plus experience in the field. So let's get started. Our objective 2.1 is compare and contrast transmission control protocol, that is TCP, and user datagram protocol, UDP, ports, protocols, and their purposes. And our first topic is TCP and UDP overview. So TCP and UDP, they are basically the core protocols of the TCP/IP protocol suite. So what does this mean? So the internet and our networks are basically run by the TCP/IP suite. You must have listened about the OSI layer. So the OSI layer is basically the theoretical model that was proposed initially to run the internet and the network. Practically, nowadays, the model that is used is TCP/IP suite. And TCP and UDP are the important and main component of this whole suite. The other important protocol is the IP. So TCP and UDP, basically they handle the data transmission over the network. So we will study the detail coming slides, that how does this data transmission takes place. And both these protocols basically operate at layer 4 of the OSI model, also known as the transport layer. And there are slightly differences and you can say variation between these two protocols. The only common thing you can say is that they both operate at layer 4. Otherwise, they differ in both reliability, speed, as well as the overhead over the network. So we will study all these differences in coming slides. So first of all, let's start with the TCP, that is Transmission Control Protocol. So TCP is connection oriented. What does this mean? It means that before sending data, it establishes a connection between the client and the server, and particularly this connection is known as three-way handshake. So it establishes a connection using three-way handshake, and it is known as three-way because it first sends, the client sends the SYN packets to the server. The server responds with the packet known as SYN ACK, and then the client finally sends the ACK packet. So these three packets are transmitted before the actual data transfer, and that's why this is known as three-way handshake. So TCP is connection oriented. Before sending data, this connection must be established using this three-way handshake methodology. It is a reliable protocol. It guarantees data delivery and retransmit lost packets. So what does this mean? This means that it is reliable. If you send data, it will be guaranteed that it will reach the destination. If some packets are lost in the network during the process of transmission, they will be retransmitted by the TCP. And the packets are received in order. So if you send packet 1, let's suppose, then packet 2, and then 3. So these will be received in order at the receiver. The receiver will receive 1, then 2, and then 3. And even if they are received without order, they are ordered before handing over to the destination application. And you can say the purpose or the usage of the TCP is for application guaranteed delivery. What does this mean? This means that those applications that cannot tolerate data loss, such as web browsing or file transfer, these applications use TCP. Now coming over to the next protocol, that is UDP, User Datagram Protocol. So as contrast to the TCP, which was connection oriented, this one is connectionless. So no three-way handshake takes place, no connection is established before data transmission. It just sends the data in bursts when the data transmission is needed. So it is unreliable as compared to TCP, so no guarantee of delivery. Some packets may be lost, and the packets are or may be received unordered. So packet may arrive out of sequence, and this application or this protocol is used in application prioritizing speed over reliability. For example, video streaming, online gaming. So when you play online game, you cannot tolerate any delay. When you press a key, you want that command to be sent immediately to the gaming server. You may tolerate some packet loss, and which will result in the poor quality of the video or of the gaming graphics, but you cannot tolerate the delay. So another analogy that just came in my mind, that you can say that UDP is like AK-47. So it just sends the data in the form of burst, like AK-47. You may miss some bullets, but some bullet may reach the target or hit the target. And TCP, you can say it is just like a sniper. So it is slow, but it guarantees the hit. Even if it misses, it reloads and then fires. So this is a crude example, but it just came in my mind. So now coming over to the ports and the protocol, and let's just few lines about the ports and protocol introduction. So ports are virtual endpoints for communication. We are talking here about the virtual ports, not the physical ports like RJ45. Virtual ports means the ports such as port 80 that is used by web service HTTP.
And the purpose and the benefit of ports are that they allow multiple applications to use a single network connection. What does this mean? This means that let's suppose we have a client and we have, let's suppose, a server, and there is a single link between these two. Let's suppose they are connecting to this Cat6 cable. But this server may be running multiple applications. Let's suppose HTTP on port 80. Similarly, this server may also be running mail server SMTP on port 25. Similarly, the client may also need to remotely manage this server through SSH. So it may also be running port 22 for SSH. So by this sentence, we mean that we have a single physical network connection, but we can use this one connection for multiple applications. And the protocols use specific port numbers, such as the protocol that is HTTP, the web protocol. It uses the port 80. Similarly, the protocol SMTP. So we will study these protocol and their port number in details in the coming slide. SMTP use port 25, and similarly SSH protocol use port 22. And well-known ports, the range is from 0 to 1023 are standard for common services. So these ports that ranges from 0 to 1023, they are known as well-known ports, and they are used by the popular standard services or protocols such as port 80, 25, 22, 23 for telnet, 21 for FTP. We will study these well-known ports and their services in. So now coming over to the some popular ports and the protocol that use these ports, and the first one is the FTP, and FTP uses two ports, 20 and 21, and the protocol that is used by FTP is TCP. So some protocol use UDP, some use TCP. So FTP uses TCP because, as we studied, we cannot tolerate file loss or data loss during file transfer. So that's why it uses TCP. So why this uses FTP uses two port number? It is because port 21 is used to control the FTP session. What does this mean? This means that when the user sends commands from clients to the server, it uses port number 21, while the port 20 is used for actual data transfer. Let's suppose when data is uploaded or downloaded from this server, then it uses port 20, such as this diagram shows. So at the client side, we have some random numbers such as 45,645, and on the server side, it uses port 21 for the, you can say, the control session, and port 20 for the data session for which data transfer takes place. So the purpose for FTP is that, of course, it is used for uploading and downloading files. Our next protocols are SSH and Telnet, and they both again uses the TCP. So SSH uses port 22, and it is basically used for secure remote access. What does this mean? This means that, let's suppose I have a client, let's suppose this is my laptop, and this is a switch, a network switch or a network router, and I am remotely configuring it. So the CLI that I am using, I may use this port SSH. I will SSH this switch, and I will configure this switch or router through CLI using this secure session. So by secure remote access, we mean that this data session is encrypted. When I send any command to this switch or server, it will be encrypted. So what does this mean? This means that even I can configure this switch or router over the internet, and all my data traffic will be encrypted, and no one will be able to interpret or use it for man-in-the-middle attack. So another related protocol is the Telnet, which uses port 23, and it is also used for remote session or for remote management of network devices, but the difference is that this is insecure. So it is insecure and it is outdated. It is same as SSH, but the only difference is that this channel or this link, when you use telnet, it is unencrypted. So if you are given a question inside exam that you have the option of using SSH and telnet, which one will you should use? So you should always select the SSH because it is secure and its channel or its connection is encrypted. Next are some email protocols, and these include these email protocols work on port 25, 110 and 143. So these are three different email protocols we will study in a moment. And all these email protocol again uses TCP because we cannot tolerate any packet loss during our email correspondence. So the first one is the SMTP, Simple Mail Transfer Protocol, and this one uses port 25, and it is used particularly for sending emails. Next in the POP3 as Post Office Protocol 3, and this one uses port 110, and POP3 is used to download and delete the emails. And the last one is the IMAP, and this one uses port 143. And IMAP basically sync your emails across your different devices. Next protocols are the DNS and DHCP. So the DNS uses port 53 and it uses both the TCP and UDP. So DNS uses both protocol UDP and TCP but for different purposes. And DHCP only uses UDP on port 67 and 68. So first the DNS. So DNS stands for Domain Name System, and it uses the important point to remember here is that it uses port 53 and it is used to translate domain name to IP address. What does this mean? This means that let's suppose we have a domain name of let's suppose www.google.com. So the computer basically don't understand this www.google.com. They need IP addresses to communicate. So this DNS basically translates this google.com to an IP address. This IP address may be anything. I am giving just an example 192, let's suppose 168.1.100. So this translation is done by the DNS. And DHCP, it uses port 67 and 68. And as I said, it uses UDP. So the DHCP is used to automatically assign IP addresses to the client, such as this access point, your Wi-Fi access point. It also has a DHCP server or DHCP configuration done. So when you connect to your Wi-Fi, your smartphone or your laptop automatically gets an IP address using this DHCP server or service on this access point. And so the DNS, it uses TCP for zone transfer and UDP for queries. So that's why it uses both these UDP as well as TCP, but for different functions. Our next protocols are web protocol, and we have two web protocol. One uses port 80 and the next one uses port 443, and both the web protocol uses TCP. So the port 80 is used by HTTP Hypertext Transfer Protocol, and it is the unsecure web browsing. So initially HTTP was used, but when you connect to, let's suppose, google.com or youtube.com using HTTP, it means that your session or link is unsecured and anyone in between, such as ISP, can see your data. An alternate and secure version of HTTP is HTTPS. S here stands for, you can say, secure, and it uses port 443, and it is the secure version of the web service, and it is by default the modern web browsing used by all the devices. So you won't see any HTTP website or web service anymore. And the security that is provided by the HTTPS is basically through SSL/TLS protocol. These two protocols basically provide the security to HTTPS. Our next protocols are LDAP, Lightweight Directory Access Protocol, and SMB. And these both uses port 389 and port 445, and both uses TCP protocol. So first of all, the LDAP, and LDAP, as I said, uses port 389, and LDAP is used for directory services such as user logins. And the next one is the SMB or SIPs. So these protocols are used inside Windows for file sharing, and they use the port number 445. Our next protocols are NetBIOS and RDP. RDP stands for Remote Desktop Protocol, Network Basic Input Output System. And NetBIOS uses port 137 to port 139, and it uses again both TCP and UDP, while the Remote Desktop Protocol, it uses port 3389 and it uses protocol TCP. So the NetBIOS uses, as I said, port 137, 138, and 139, and it was used in legacy Windows edition for sharing. And the RDP, or Remote Desktop Protocol, it uses port 3389 and is used for remote desktop access. So let's suppose you have a laptop over here and you want to access another laptop or another Windows computer. So you use this protocol to access the session of this remote desktop. So coming over to Objective 2.2, and this Objective 2.2 is explain wireless networking technologies. So the wireless technologies or wireless networks basically use radio signals to transmit data. And the common technology in wireless technology include Wi-Fi, Bluetooth, NFC, and RFID. And each of these technology has different ranges, speeds, and use cases. So now coming over to wireless frequencies, 2.4, 5, and 6 gigahertz, which are used by different wireless technology for different purposes. So 2.4 gigahertz is a long range frequency, and it has more interferences because it is used by multiple services. It is used by Bluetooth. It is also used by Wi-Fi and microwaves. Next one is the 5 gigahertz frequency. This is Wi-Fi standard 802.11 AC, used by Wi-Fi 802.11 AC. And this has faster speed as compared to 2.4, but it has less range, and as well as it also has a benefit of less interference as compared to 2.4 gigahertz. And the latest one is the 6 gigahertz, which is used by Wi-Fi 6. It is the newest, ultra fast, and it requires newer hardware, and it is used, the 6 gigahertz is used in Wi-Fi 6E. So by newer hardware means that if you have old access points, it won't run the Wi-Fi 6. You will require newer access points that are Wi-Fi 6 enabled. So now coming over to Wi-Fi channels and regulations. So regulatory bodies such as FCC in the US and ETSI in the EU or European Union basically define which frequencies and channels can be used for what purpose and how. So regulations or regulatory body vary by country, such as FCC in US, ETSI EU. So these regulatory body ensures compliance with local regulation when configuring wireless network. So for example, you are configuring your wireless network, so you must ensure compliance with your local regulation, that which frequency you can use for Wi-Fi and how. So the next topic is the channel selection inside the wireless channel. So what does this mean? So when we said that we have, let's suppose, 5 gigahertz of frequency for Wi-Fi, so this one frequency has then further multiple channel. You can say that multiple paths to send and receive data. So you should choose less congested channel to minimize interference. So there are multiple channels and you should look for the channels that are least congested or that minimize the interference. So you can use different tools to analyze channels that are used in environments such as Wi-Fi analyzer. We will study Wi-Fi analyzer in a while. And overlapping channels can cause significant performance degradation. What does this mean? This means that let's suppose you are using a channel number 1 and the same channel is, let's suppose, also used by another access point nearby. So since these both are using same frequencies and same channel, so there will be interference and performance will be degraded. So what is the channel width? So as I said, we have different channel and each channel has a frequency width. So wider channel means have faster speed, but we will have more interference because more channel will fall in the same channel width. For a common channel width are 20 megahertz, 40, 80, and 160 megahertz. So this 160 megahertz will have the highest speed, but it will also have the maximum interference. So you should trade off between the interference and the speed. So you should choose the width based on the device supporting the width and your network needs. So now the next topic are the frequency and bands. So different frequency bands. So these are known as bands. So we have the 2.4 gigahertz, 5 gigahertz, and 6 gigahertz band. And then each of these have different channels allocation. So 5 and 6 gigahertz generally offer more non-overlapping channels compared to 2.4 gigahertz. So as we said earlier, 2.4 gigahertz frequency band has more interference as compared to 5 and 6 gigahertz because the channel allocation in 2.4 has more overlapping channels. So using non-overlapping channel is key to reducing the interference in dense environments. So let's take an example. Let's suppose we have 2.4 gigahertz of bands. So in this 2.4 we have multiple channel, and channel 1 basically uses frequency range from 2.401 to 2.423 gigahertz. Then channel 2 starts from 2.406 gigahertz and overlaps with channel 1. So you can see that this is the range of channel 1, while channel 2 is also starting from 2.406 gigahertz. It means this lies between in this range, so there will be interference and it actually overlaps with channel 1. So in 2.4 gigahertz, the channel 1, 6 and 11, they do not overlap with each other. So when you are using 2.4 gigahertz and your device supports the channel selection, then you should select these channel because they are non-overlapping channel. So now some comparison or summary of the 802.11 Wi-Fi standards. So 802.11a, it has the speed of maximum speed of 54 megabit per second. It uses 5 gigahertz frequency band and it was introduced in 1999. 802.11b has 11 Mbps speed. It uses 2.4 gigahertz band and it was again introduced in 1999. 802.11g has again 54 megabit per second speed. It uses 2.4 gigahertz frequency and it was introduced in 2003. 802.11n, also known as Wi-Fi 4, has 600 Mbps speed. It uses both the 2.4 and 5 gigahertz frequency bands and it was introduced in 2009. While 802.11ac, also known as Wi-Fi 5, it has a maximum speed of up to 3.5 gigabit per second. It 5 gigahertz frequency band, and it was introduced in 2013. And the latest and newest is 802.11ax, which is also known as Wi-Fi 6 and 6E, and it has a maximum speed of 9.6 gigabit per second, and it uses three frequency bands, 2.4, 5, and 6 gigahertz, and it is used 2019 onward. So now coming over to another wireless connectivity technology, that is Bluetooth. So it is a short range wireless technology for connecting devices. You can say it is the one of the shortest range technology as compared to other wireless technologies such as cellular, Wi-Fi, and it is used for accessory nowadays such as headphones, portable speakers. It can also be used for file transfer between smartphones and laptops, and it operates in 2.4 gigahertz frequency band. So that's another reason for 2.4 gigahertz frequency to be congested and has performance degradation. Next is the NFC, that is near field communication. So this is a very short range, even shorter than the Bluetooth. It has a range of few centimeters, and it is used in contactless payments for quick pairing such as this one. So nowadays we have NFC enabled ATM, and if your mobile is also NFC enabled, you can do payment through NFC, which is contactless, and it is secure, and it uses very low power because it works at very short distances. Next one is the RFID, that is radio frequency identification. So it also uses radio waves to identify and track tags attached to the objects. And tags can be passive, that means the tags do not require any battery, or they can be active. They are battery powered. So it is used in inventory management, access control, and toll systems, such as here we can see that this user is doing inventory management by scanning the RFID tag on this package. So different frequency ranges with varying read ranges. So it also uses different frequency and has different read ranges. Some has small range, some may have longer distances of reading the tags. So objective 2.3, summarize services provided by networked hosts. And the first service is the DNS server. The DNS server provides the DNS service, that is domain name system. So DNS basically translates your domain names to IP addresses, such as when you type www. Let's suppose google.com, that is a domain name, and that is translated by DNS to an IP address such as 192.168.1.1. So this is the private IP address I am giving just for an example. So that's the basic purpose of the DNS server, and it allows users to use websites name instead of IP addresses. So it is easy to remember www.google.com as compared to the numbers such as 213.86.61 and so on. So that's why we use the domain name. An example is again google.com translated to this IP address. Next service is the DHCP, that is Dynamic Host Configuration Protocol. And this protocol is used to assign IP addresses automatically to the clients inside the network. And besides the IP addresses, the server also provides the subnet mask, gateway, as well as the DNS info. DNS info means the DNS server. And this protocol basically saves time and avoids conflicts. What does this mean? So if you have, let's suppose, 100 clients inside your network, And if you want to manually configure or assign static IP addresses, subnet mask, gateway, and DNS server to all these clients, it will take a lot of time. And you may also give two clients the same IP address and you have the conflicts. While the DHCP server, it avoids conflicts. It does not assign same IP address to multiple clients, and it assigns the IP addresses automatically without any manual configuration or intervention. Next is the file share server. So these servers are used to share files between clients and servers over the network. File share server or file servers are basically centralized location for storing and accessing files for the clients. So they support permissions as well as access control. So if a client has the permission and has the access permission to the files, only then will the server allow the access to the files. And the common protocols used by file share servers are SMB and NFS. Next are the print servers. So these servers basically manage print jobs from multiple clients. So you have a print server inside a network, and your multiple clients inside the network can give print commands to this print server, and this server basically manages the print jobs and print queue from all these clients. It also controls access to network printers. So each client must be first configured and allowed to access the print services. And it is also the centralized location to track usage and printer status. So this print server basically logs the number of prints that has been given by this client as well as this client. So this is also a centralized location for monitoring your print usage, as well as the print status means the printer cartridge status as well as its health. Next are the syslog servers. So these servers basically collect and store system logs from different devices and other servers. And it is basically a centralized location for logs, and these logs are then can be used to monitor and troubleshoot different servers inside your network. And syslog protocol basically uses UDP port number 514. So this is important to remember. And one of the popular syslog server or service is SIEM, that is Security Information and Event Management. So this is a specialized solution that is used. For example, if I give you an example, QRadar is a popular SIEM solution from IBM, and this solution is used basically to collect logs from all network devices from different servers, and then here centrally you can then give configure different rules, policy violation, and this is a very popular solution. So this is a generic term, the syslog server, and this is one of the syslog server solution, QRadar from IBM. Another popular solution is the Splunk. The IBM and Splunk, these are the industry leading solutions. The next network host are the web servers. So these basically deliver websites and web application or HTTP and HTTPS protocol. As we studied, HTTP is the unsecure or unencrypted, and HTTPS is the secure version of the web server. And it hosts HTML, CSS, JavaScript, and media files and pages. And the common software that hosts the web servers are Apache, Nginx, and IIS. This is from Microsoft. AAA servers, that is authentication, authorization, and counting. So authentication basically verifies the user identity, such as when you log in your username and password, this is done through the authentication. Authorization then grants user the access to different rights. So first you authenticate, and then you are granted the access based on your user. And the last step is the accounting. So when you perform certain tasks inside the application or the server, your each and every activity is logged or tracked using the accounting service. Next are the important database servers. So they basically store, manage, and serve data for all the applications. So database is basically at the back end. At the front, you have the application interface. But when you enter data or you save data or you retrieve data, it is all done from the web, from the database server. So this database server basically understand or use structured query languages such as SQL or SQL. And as I said, it is backend for the web application and business tools. Next is the NTP, that is Network Time Protocol servers. So these servers basically synchronize time across all the devices on the network. So it is very important that all the devices on the network have the same time inside their devices or services. And it is critical for these services, specifically for logs, authentication, and coordination. And NTP uses UDP protocol on port 123. So a quick quiz time: which server role assigns IP address to devices? And the options are option A DNS, option B DHCP, option C AAA, and option D NTP. And the correct answer is, I hope you people know the answer, we just studied it. It is DHCP, Dynamic Host Configuration Protocol. DNS is used to translate domain name to IP addresses. AAA is authentication, authorization, and accounting. And NTP is used to give a centralized time to all devices inside a network. So basically, the NTP server works such that your all devices, let's suppose you have different devices inside network, this is your NTP. They ask for the time from this server. So this, you have one source of time inside network. So all these devices basically have the same time. Next topic is the internet appliances, and the first appliance is the Unified Threat Management, that is UTM. So UTM basically combines multiple security functions in a single devices, and these functions may include the firewall, intrusion prevention system, that is IPS, antivirus, anti-spam, and web filtering. So usually we have dedicated device for firewall, IPS, antivirus, and other application, but UTM combines all these services to a single device. So it simplifies security management. So instead of having, let's suppose, 5 or 6 devices, you have a single device. So it gives simplification and easy management. And it provides comprehensive protection because you have multiple functions inside a single device. Next appliance is the spam gateway. So spam gateway basically analyzes the incoming email traffic inside your organization. It identifies and blocks spam emails and phishing attempts. It improves email server performance because all the spams are basically blocked and they never reach the email server. It also enhances network security because the threat from the phishing attempts and spams are blocked by the spam gateway. Next is the proxy server. So proxy server basically acts as an intermediary between the clients and the server. You can say that, let's suppose you have a client, and let's suppose you have a web server over here. So the proxy basically sits between your clients and the server, and it filters or it monitors all the requests from the client to the server. So it can improve security by hiding internal IP addresses. What does this mean? So it means that this server will see the IP address of this proxy. It will not see the IP addresses of the internal clients. It can improve performance through caching. What does this? This means that let's suppose this clients access a web page from this server over the internet. So this page is basically cached over here. And next time when another client wants to access the same page, it doesn't need to go all the way to the internet. It will be it is available and is provided by this proxy server. So you can say that it can also act as a cache server. So it can also control web access. So let's suppose you can implement web traffic control. You can blacklist different IP addresses, different malicious websites over here, or even social media sites. Let's suppose your organization wants to restrict user to specific servers and wants to prevent Facebook browsing. So you can block Facebook application through this proxy server. So now summary of the internet appliances role. So the spam gateways are used for stopping the unwanted at spam emails. UTM basically it is all in one security box that combines multiple security functions such as IPS, antivirus, and firewalls to a one security box. Load balancers basically share the traffic load between multiple devices. So we didn't study load balancer in detail. So load balancer, let me give you an example. So this is a load balancer, and these are, let's suppose, different web server. We have web server 1, web server 2, and web server 3. So this load balancer has multiple advantages, and here are, let's suppose, our clients. We have, of course, multiple clients. So when these clients wants to access the web servers, they first come to the load balancer, and load balancer then distributed the loads among these servers. So let's suppose client 1, 2, and 3. Client 1 comes and the load balancers forwards the request to, let's suppose, web 3. Then client 2 request is forward to, let's suppose, web 1, and client 3 request is forward to web 2. So this way the load is equally distributed among servers, so it enhances performance. Another advantage is the availability or failover. So let's suppose our web server 2 fails due to any reason. So now the load balancer won't transfer any request to web server 2. It will transfer the request to the remaining available server. So user won't experience any downtime or any interruption of the services. So these are some of the advantages of load balancer. And proxies, as we studied, it filters and protect internet access from the external network. Our next topic is the legacy and embedded systems. So these systems basically run on outdated or fixed purpose hardware and software. So in industry, we have some hardware that are for one specific purpose, but they are outdated and legacy. So these are still used in industries because they are very costly to replace, and compatibility is another issue. So these legacy systems often lack modern security features because they are outdated and they cannot receive updates. So one of these systems is the SCADA, that is supervisory control and data acquisition. So this is a type of industrial control systems. It is used to monitor and control industrial processes such as power plants, water treatment facilities, nuclear power plants, etc. And this it basically relies on specialized hardware and software. And for connectivity, it uses industrial network protocol. So it does not use the regular TCP/IP. It has specific special purpose industry network protocol. And security is a critical concern because if these protocols are disrupted, it means your whole power plant or your water treatment facilities may be disrupted or even contaminated. Next topic is the IoT, that is Internet of Things devices. So these are basically the network of physical objects known as things that are embedded with sensors, software, and other technologies such as these things. And they enable data exchange with other devices and systems over the internet. They have a wide range of applications such as they are used in smart homes and wearables such as your smartwatch, and also used in industrial Internet of Things networks. So for connectivity, they primarily use wireless networks such as Wi-Fi 802.11 standards. They also use Bluetooth, NFC, cellular network, and LPWAN. Security and privacy are significant concern for these IoT devices. So what are some challenges with the legacy SCADA and IoT? The first one is that these systems are legacies, particularly the SCADA and industrial system. So they often lack modern security features, making them vulnerable to latest attacks. The challenge with embedded system or SCADA is that they operate or they are embedded inside, used inside critical infrastructure such as power plant, and security breaches inside these systems can have severe consequences, such as you can say that beside the physical attacks, the power plants in recent Russia-Ukraine war, the power plant infrastructure were also targeted through web attacks, cyber attacks by Russia inside Ukraine power plant, and they were disabled or shut down for multiple hours or even days. IoT, so vast number of devices create a large attack surface. Privacy is also a concern. What does this mean? This means that if you have inside home multiple devices such as your light bulbs, your TV, your refrigerator, all these have connectivity. It means you have a large attack surface. Any of these devices can be uh, penetrated by the attacker. Privacy is also a concern. So if one of your devices, let's suppose your smart TV is compromised, it means that smart TV has has camera, it has also has mic. So anyone can use these cam and mics of your smart TV to compromise your privacy inside your home. Security is a paramount concern across all these specialized systems. So a quiz time, a quiz quick. Which type of system is most likely to control a city traffic lights? Options are option A, IoT device, option B, SCADA, option C, legacy embedded system, and option D, proxy server. And the correct option is option B, SCADA. And our objective 2.4 is explain common network configuration concepts. And our first topic is DNS record types. So we studied the DNS, that what is DNS. Now we will study different DNS record types. So DNS records basically stores information about a domain. So different record types serve different purposes. First one is the A records. So A record basically maps a host name to an IP version 4 address. For example, example.com may be mapped to 192.0.2.1. Next is the Tetra A record. So this basically maps a host name to IP version 6 address. For example, example.com may be mapped to an IP version 6 address. Next record type is the CNAME, which is the canonical name. So it creates an alias for another host name, that is the canonical name. For example, www.example.com may have an alias of example.com. And the last one are the MX records. So these basically specifies mail servers responsible for accepting email for a certain domain. For example, example.com may have an MX records of mail server.example.com. So example.com domain have the mail servers as MX record. Next are the TXT or text records. So these holds basically text data, and these are used for various purposes including domain ownership verification and spam prevention. So remember, it is important that the text or TXT records are used for spam prevention, and spam prevention techniques include SPF, DKIM, and DMARC. So we will study now these one by one. So DKIM is basically domain keys identified email. So it adds a digital signature to your emails. And what does digital signature do? It verifies that the email was sent by an authorized mail server for the domain. So if your device receives an email from a domain server that is not authorized by DKIM, it will be flagged as unauthorized or as a spam. Next one is the SPF, that is Sender Policy Framework. So it specifies which mail servers are authorized to send email on behalf of a domain. It also prevents email spoofing. And last one is the DMARC or DMARC, which is domain-based message authentication, reporting, and conformance. So it builds on SPF and DKIM. So it specifies how receiving mail servers should handle emails that fail SPF or DKIM checks. So this means, what does this mean? This means that if an incoming email check one of these steps, SPF or DKIM, then what should be done with that email? It is decided by the DMARC. Our next topic is regarding the DHCP different concepts, and the first one is the DHCP leases. So what is DHCP lease? So DHCP assigns IP addresses for a limited time period called a lease. So this is the lease. So you can configure that for how much time the IP address should be assigned to a client, and when that time passes, the IP address is renewed by the client. So here we can see that the lease time is almost, I think this is 24 hours. This number is in seconds. So you can configure this inside your DHCP configuration. So devices must renew their lease periodically to maintain their IP address. So after this time, the device must, before this time, the device must renew its IP address, so that and when the IP address is renewed, the lease is also renewed. So it allows for efficient reuse of IP addresses on the network. So let's suppose a device disconnects itself from the network. So if a device does not renew its IP address after this lease time, it means the device has gone or has shut down, and this IP address will then be assigned to another client. So in this way, it allows for efficient reuse of IP addresses to the client. If a client is shut down due to any reason, its IP address will be assigned to another client after the lease time. Another concept is the DHCP reservations. So DHCP reservation basically allows administrators to assign a specific IP address permanently to a particular device. So you can configure that. Let's suppose this IP address 192.168.100.10 is always assigned to my laptop. You will give the MAC address and the IP address, and you can also give the description. So each time the DHCP server, when you connect your laptop to the network, your laptop will always be assigned this IP address. So it is easy for efficient for efficient management because you always know that your laptop has an IP address of 100.10. It can also be used for other servers, such let's suppose you have a print server inside your network. So and you have let's suppose multiple clients. So your client should know the print server IPs. So if the print server IPs changes each time, it will be difficult for the client to give the print commands. So you can reserve a specific IP address for the print server, and the clients will always know that our print server has the same IP address. So reservation is typically based on the device's MAC address, and it is useful for servers, printers, or other devices needing a consistent IP address. Another important concept is the DHCP scope. So it is basically the defined range of available IP addresses. So when you define a DHCP or configure a DHCP server, you will need to give the DHCP scope or the DHCP range, which you configure by giving the starting IP address as well as the ending IP address. So the DHCP server will now assign IP addresses starting from this 80 up to 90. And if let's suppose these are let's suppose 11 IP addresses and you have let's suppose 12 clients, so when the 12th client comes, it won't be able to get any IP address because the range or the scope is exhausted. So you can then increase the scope or increase the range. For example, as in this example or in this example, the range is or the scope is 192.168.1.100 up to 192.168.1.200. So you have almost 100 or 101 IP addresses in this scope. So must match subnet mask and gateway setting. What does this mean? This means that your gateway must also be in the same network, and your subnet mask must also match this scope. So for example, if you have a gateway 192.168.100.1, it won't work because your scope is in 1.80 network or 192.168.1 network, but your gateway is in 192.168.100 network. So here it must be 1 as well. Another concept is the DHCP exclusions. So DHCP exclusion is the IP addresses excluded from the automatic assignment. What does this mean? This means that you exclude certain IP addresses from the DHCP server, and DHCP server won't assign this IP address to any server or any device. And then you can use this IP address to manually give it to your devices. So the difference between exclusion and reservation is that in the reservation, the DHCP server basically assigns the IP address to the same device each time based on the MAC address, while the exclusion exclude the IP address from DHCP server assignment altogether. You can use those excluded IP for any purpose. You can manually assign these IP addresses to your devices. So they are used for static devices outside the scope, and it prevents IP conflicts. So let's suppose you have given a static IP address to a device and you have not excluded the IP address inside DHCP configuration. So the DHCP server may also assign same IP address to another device and you will have conflict. But once you have excluded this IP address in DHCP configuration, it will no longer be assigned to any device. Another important concept is the VLAN, that is virtual LAN or virtual local area network. So what is a VLAN? It is basically VLAN logically divides a physical network into multiple broadcast domains. So by default, when you connect your devices to a network switch, by default this switch has a one broadcast domain and all the devices are in the same broadcast domain. But when you configure different VLANs inside the switch, each VLAN is now a separate broadcast domain. And why we do use VLAN? So we improve security. So for example, if we want that the traffic of this device should not be listened by these devices, so we can configure this device in a separate VLAN and this device in a separate VLAN, so their traffic is isolated. As we said, they have separate broadcast domain. So when this device broadcasts a traffic, it will not be listened by this one or this one. When this device broadcasts a traffic, it will be listened by this one, but not by this one. So it also reduces congestion because it limits the broadcast traffic, because now we have multiple broadcasts and the traffic is limited to a specific broadcast domain. And it also simplifies management, so it groups devices by function, so you can it is easy to manage these devices, and you can, let's suppose, apply different policies on these devices by groups. For example, as we can see in this example, you can use VLAN 2 for accounting. Accounting people will be, their client will be configured in this VLAN, and you have another VLAN 3 for marketing. So marketing clients will be in this VLAN. So the client inside accounting and marketing won't be able to communicate with each other for security. Similarly, if you have other clients such as guest, you can use another VLAN for them. So you can configure theoretically 4096 VLANs. So this is the range of the VLANs. The first VLAN number 1 is basically reserved. It is the default VLAN of this device, and you can configure onward VLAN 2, 3, 4 up to 4096. So some other concepts about VLAN. So for implementation, you need VLAN capable switches. So the simple switches, or you can say the unmanaged switches, they are plug and play, and they don't give the option of VLAN configuration. But the modern switches, they have the capability so that you can configure them for different VLAN. So the device must be capable of VLAN, and VLAN basically uses tagging mechanism, that is it uses IEEE 802.1q standards. And if you want to, as we studied in the previous example, let's suppose we have multiple VLAN 2 and VLAN 3. So if there is a need that you want that VLAN 2 and VLAN 3 should be able to communicate, then you need a layer 3 device or router. So if the switch is layer 3, nowadays almost all the modern switches are layer 3. Layer 3 means that they can also perform basic routing. And the port types of VLANs can be access. So the access means that a single device is connected to the port. For example, your laptop will be connected to access VLAN. Trunk port basically carries multiple VLAN. Here we can see that this switch has multiple VLANs, 3, 4, 2, 1. Similarly, another switch which is connecting another building with this switch, it also has multiple VLANs. So this port or this cable between these two switches must be trunk, because it will need to carry VLAN 1, 2, 3, 4. So when you need an interface or a port to carry multiple VLAN, it will be configured in trunk mode. But when a single device is connected to a port, that port will be in access mode. Another important concept is the virtual private network, or VPN. So VPN is used for encrypted tunnel over public network. So let's suppose you have a client over here and you want to access some data, secure data over the public network, that is internet. Then you will use the VPN, and VPN will encrypt your connection. So why we use VPNs? To access private networks remotely, bypass geographic restriction. What does this mean? This means that let's suppose you live in a country X where let's suppose Netflix is not allowed. So what you can do, you can configure VPN and you can change your location using the VPN to another country Y where Netflix is allowed, and this way you can bypass the geographic restrictions. And it is also used for secure public Wi-Fi connection. So let's suppose you are using Wi-Fi inside a cafe which is not very secure, then you will use a VPN to securely use the internet or access your files inside that public Wi-Fi network. An example, or you can also say types of VPN. So we have two types of VPN. One is the site to site or office to office. So this type of VPN is basically between two devices, that is from firewall to firewall. Let's suppose you have a headquarter of your company in a city and a branch of that company in another city, and you have multiple employees over here and over here as well. So you can configure site to site VPN between these sites so that all these client traffic will be encrypted between these two sites. Another one is the remote access, which is employed to office. So let's suppose you have a single employee and he is working from home. So this type of VPN is used on a single client, such as inside your laptop or inside your PC, and you use that VPN to directly connect to the company network. So now some key differences between the VLANs and VPN. So VLANs basically create logical segmentation within a private network as we studied, while the VPN creates a secure tunnel over a public network. The purpose of VLAN is organization, that is management, security, and it also gives a benefit of performance within a LAN because it divides broadcast domain into multiple broadcast domains. While the purpose of VPN is secure remote access and privacy. Objective 2.5, compare and contrast common networking hardware devices. Introduction to network hardware. So routers and switches are fundamental networking devices, and these devices facilitate communication and data flow within and between networks. So switch is basically used to route or communicate data within a network, but when we need to route traffic between different networks, we need routers. Understanding their distinct function is crucial. First of all, routers. So routers connect multiple networks together. For example, when you are browsing internet inside your home, so your home network is connected to the internet, which consists of lot of different networks. So you need a router to do this routing from your home network to the internet. So router also determines the best path for data packets to travel. So there may be multiple paths from your client or from your device to the destination, but the router selects the best and optimal path for the data packets to travel. Routing or router basically operate at layer 3 or at the network layer of the OSI model. So if you are asked inside exam that routers operate or function at which layer, your answer should be layer 3 or the network layer of the OSI model. On the other hand, switch operates at layer 2. So router basically uses IP addresses to route traffic. And the modern routers have the firewall capabilities where you can block and allow different type of traffic. Next device is the switch. So switches basically connect devices within the same local area network or LAN. And switch forwards packets directly to the intended destination device. What does this mean? This means that the devices are basically connected directly to the switch ports. So for example, if you want to send traffic from this laptop 1 to laptop 2, the router will forward traffic directly to this device. On the other hand, the routers may be forwarding traffic to another router. And the switch operates at layer 2 or the data link layer of the OSI model. So this is important. And switch basically uses MAC address to forward traffic. So when the laptop wants to send data to this another laptop, it uses the laptop IP address. But when the switch actually forwards the packet, it does this using the switch network card MAC address. So each of these switch port has also its own MAC address, and this MAC address of the switch NIC or network interface card, it is basically learned and saved by the switch. So the switch knows that this MAC address of this laptop is basically connected to my port number 3, and so it forwards data through MAC address. So we have two type of switches, that is managed and unmanaged switches, and these are this is the comparison table of managed and unmanaged switches. So as far as control is concerned, the managed switches are controllable, or you can say configurable. You can configure different features such as VLANs, quality of service inside these managed switches. You can assign IP addresses, etc. While the unmanaged switch, they are basically plug and play. You power on the switch and directly connect your devices to this switch, and they also basically work or operate at the same VLAN one, so you cannot configure different features inside this switch. Security, so it has advanced security features because you can configure VLANs, quality of service, ACL, access control list, etc. So it has basic security features because you cannot configure these advanced features. Cost, it is of course expensive because it has advanced feature, while the unmanaged switch is less expensive. And the managed switch is basically used for businesses and large networks, while the unmanaged switch you can use for small home and office network where you have a few devices. Our next network hardware is the access points or APs. So these allows wireless devices like laptops, mobile devices to connect to your wired network. So let's suppose your access point is connected to the internet through wired network, and your mobile clients such as your laptop and your PC can wirelessly connect to this access point, and then this access point basically allows these devices to access the internet. So they transmit and receive data using Wi-Fi standards such as 802.11n, AC, and X, and the access point basically connect to the wired network infrastructure. For example, other switches using through these Ethernet ports and Ethernet cables. And access point basically provide wireless coverage for a specific area, usually within a 100-meter radius. And this coverage also depends upon the other interference such as walls, trees, etc. If there are less walls and less tree, the coverage area will be more, and if there are thick walls and rooms, the coverage area will be reduced. Next are the patch panels. So patch panel are basically passive devices that centralize and organize network cable connection. Passive means they are not powered. They are basically, these are cables, they are punched at the back of the patch panel, and at the front these are basically RJ45 enable connector connection. So you can plug your RJ45 connector and cable inside these patch panel. So these are passive. Basically, they are the extension of these Cat6 cables. You can use this patch panel for easy management and organization of cables. So they provide termination point for Ethernet cables as shown here from various locations. And they allow for easy reconfiguration and management of network connection using patch cables. So once patched, you can use these patch cables to connect these network or cables to these network devices. So they improve cable organization and troubleshooting. Our next hardware device is the firewall. So these are security devices that control network traffic. So they allow or disallow different devices and network packets to the server or different services. So they filter incoming and outgoing traffic based on defined rules. So you can define different rules on the firewall that, let's suppose this IP address 192.168.1.100 is allowed. It can access services, while another IP address 192.168.1.101, this one is not allowed. So you can configure this type of rules. It can be hardware based, or you can also use software application firewall, such as you must have seen Windows firewall. So this is a software based firewall, while inside organization where we have big networks, we use hardware based firewalls. So it helps protect network from unauthorized access and malicious threats. And it often integrates into routers or UTM devices. As we studied, UTM devices has the firewall functionality built in. Modern routers also have some features of firewalls. Another concept or network hardware is the power over Ethernet or PoE. So PoE basically delays, or you can say this is not delays, it is basically relays. It relays power and data over Ethernet. So this is, you can see, a PoE based device. So this cable brings in data and you connect your, let's suppose this is a camera, you connect this to this another cable. So this camera receives both the power as well as the data from this cable. So you can say that, as the name indicates, power over Ethernet, this device receives power over this Ethernet cable. This is normal Cat6 or Cat7 cable. And multiple devices are supported, can use the PoE functionality, such as the IP cameras, voice over IP phones, wireless access points, etc. And we have different standards of PoE. Simple PoE, which is 802.3 AF, it gives power up to 15.4 watt. PoE Plus, which is 802.380 standard, it gives power of up to 25.5 watt. And the PoE Plus Plus, which is 802.3 BT, it gives the largest power, which is 51.7, which is 51 to 27 watt. So what are some different components of PoE? One is the injector. As we saw in the previous diagram, this one is basically injector, which injects the power. So the injector basically used to add PoE capability to a network segment. So as we saw in the previous example, your network cables come over here and you then take an exit cable that is connected to the device, such as IP camera, that requires power as well as data. So it is connected between a non-PoE switch and the PoE powered device. So the switch here, this switch does not have built-in PoE ports. So that's why you can use this power injector with this un-PoE switch. Take power from a, so this PoE basically takes power from a wall outlet and inject it onto the Ethernet cable. So this is powered by your normal home power supply or power outlet. So another thing is that modern switches have built-in PoE ports. So these network switches with built-in PoE functionality provide both data connectivity and power to the connected PoE-enabled devices. So this simplifies network deployment because with the PoE-enabled switches, you no longer need these PoE injectors. So your network is simple without an additional device such as PoE injectors. Our next appliance or network hardware device is the cable modem. So it connects devices to the internet via coaxial cable that are used for cable television, such as this. So these provides high-speed broadband internet access, and they basically modulate and demodulate signals for data transmission over cable infrastructure. Next device is the DSL, which is digital subscriber line. So it uses regular telephone line that is twisted pair. As you can see, this connector is basically where the telephone line or cable plugs in, and this connector is known as RJ11. So this is smaller than the Ethernet RJ45 connector. So the types of DSL includes ADSL, which is asymmetric digital subscriber line, and it gives faster downloads. And next one is the symmetric DSL or symmetric digital subscriber line, which has equal downloads as well as uploads. So the asymmetric has faster download but lower upload. Usually we don't upload much, we download things. We download much more than we upload. So in the ADSL, we have faster download speed but slower upload speed, while in the SDSL, we have equal upload as well as download speed. So it is distance sensitive since it uses the copper twisted pair cable, so it works at limited distance. So if the distance increases from your ISP, the speed also decreases. And in the modern network, we uses the optical network terminal or ONT for internet connectivity. So it is used in the fiber to the home or FTTH networks, and it connects a user's device to the fiber optic cable. So it basically converts optical signals from the fiber into electric signal that devices can understand. And benefits of ONT are that they give faster speeds of up to 10 gigabit per second because they use optical fiber. So optical fiber has greater speeds as compared to the copper or Ethernet cable, and they are more reliable than copper. They also work at longer distances as compared to copper. So let me get back. So this is an example of an ONT. So basically, this is the fiber that is coming inside your network. This is a dumb devices. This fiber optic is spliced over here, and then a cable is exited from this fiber device. It is not powered, it is passive device, and it enters your ONT. So this is fiber optic port, and then you can, this is also most of the time a Wi-Fi enabled device, so you can use wirelessly. Your device can connect to these devices through Wi-Fi, or this also has Ethernet ports. You can also connect your device through Ethernet cable. So now some comparison of internet connection types. So the cable modem uses the coaxial cable. The medium is coaxial cable. DSL uses the phone line, is also basically copper cable, and the fiber or ONT using fiber optic cable. The speed, cable modem has up from 100 Mbps to 1 Gbps. DSL and this cable modem are rarely used nowadays. ONT is the latest standard. So DSL has a speed of 5 to 100 Mbps, while the ONT has it is the fastest of all. It has 100 to 10 Gbps per second speed. Latency, so cable medium has medium latency, DSL has the highest latency, while fiber optic or ONT has the lowest latency of all these. Next topic is the network interface card or NIC. So this is hardware component in a device such as your computer or network that allows it to connect to a network, and it provides a physical port such as this one, that is Ethernet, or it can also be a wireless. It can also be wireless capable port that is not visible but embedded inside the device, such as your laptop. So the types of network interface card may be integrated, such as inside your laptop, PCIe add-on cards such as this one, or USB adapters such as this one. So these are integrated ones. These are usually found inside switches as well as your modern day laptops, while these are used for some devices such as your Apple MacBook or other slim laptops may not have the RJ45 connector, then you can use the USB enabled RJ45 adapter. Another topic is the physical media access control address, that is MAC address. So the MAC address is basically unique hardware ID on every NIC or network interface card that we just studied. So it is 48-bit address such as this one. These are hexadecimal digits. So the first three octets are known as OUI, that is original. I don't remember this abbreviation right now, but this OUI, the first three octet identifies the manufacturer. So let's suppose if this your NIC, your laptop is from Dell, it is most probably these initial three octet will represent Dell, and the last three octets they are device specific. So this will be unique to this laptop. If there is another Dell laptop, this will be same, the first octet, because they will again represent Dell, but this will be different because this is unique for each device. And these are also used by switches to forward data. So switch port RJ45 or network interface cards or ports also have their own MAC addresses, while the laptops or devices that are connected to these switch ports, the switch also forwards the data to these devices using these MAC addresses, as we just studied. So the MAC address basically works at layer 2 or data link layer. So this is important. So now a quick quiz time. So the question is, which connection type uses light pulses for data transmission? And the options are cable modem, DSL, ONT, or NIC or network interface card. And the correct option is, of course, ONT, optical fiber, because optical fiber basically uses light for data transmission. So the ONT basically works with optical fiber, while the rest are basically use electrical signals. Objective 2.6. Given a scenario, configure basic wired and wireless small office, home office, that is SOHO networks. And our first topics in SOHO networks is IP addressing. Understanding IP addressing. So devices inside the network need IP addresses to communicate with each other. And the IPs can be manually or statically assigned to the devices, or they can be assigned through DHCP dynamically. So the IP can be IP version 4, IP version 6, and APIPA. So we will study all these concepts in a while. So all these concepts play a vital role inside our SOHO networks. So first of all, the IP version 4 addressing. So IP version 4 uses a 32-bit address format such as this one, 192.168.1.10. So these are decimal digits, or you can say octets, and each octet is 8 bits. So 4 into 8 is equal to 32 bits. So the IPv4 address size is 32 bit. And there are limited number of available addresses due to the fact that we have 2 raised to the power 32 addresses. So these are already exhausted, so limited number of IPv4 addresses available. And IPv4 is further divided into public and private IP address ranges. So what are these two ranges? So the private IP addresses are basically reserved for use within private networks such as your small office, home office network, or inside organization private networks. And since these addresses are used inside private networks, inside your home, inside your office, so they are not basically routable on the public internet. So what does this mean? This means that let's suppose you have a website such as the google.com. So google.com cannot use a private IP address because people are accessing google.com over the internet, and since private IP addresses are not routable over the internet, you cannot use IPv4 address over the internet. And the private IP addresses have basically the following ranges. So the first range is from 10 to 10.00 to 10.255.255.255. So anyone and everyone can use these addresses inside their private lanes. Second range is 172.16.00 up to 172.31.255.255. And the third range that most commonly used is 192.168.00 up to 192.168.255.255. These can also be written in this format. The first one is 10/8. Second one is 172.16/12, and the third one is, so let me get back, the third one is 192.168/16. So this number basically use the number of bits that are reserved for the network. So in the first one, only the first octet, the 10, is for network. Rest all the octets can be used for host addresses. Similarly, in this network, the first 12 bits and the first 16 bits, are the first two octets are reserved for the network and the last for the host. Next is the IPv4 public addresses. So as the name indicates, these addresses can be publicly used over the internet, and these are basically globally unique addresses assigned to organization. What does this mean? This means that if a public IP address, let's suppose 8.8.4.4, is assigned to an organization, it is unique. It cannot be assigned or cannot be used by anyone else, while the private IP addresses can be used by everyone inside their own private network. So they are routable on the internet as compared to the IPv4 addresses. Your home router typically has one public IP address assigned by your ISP. So inside your home router, you use these private IP addresses for your devices such as your PC, your laptop, your smartphone. But when you need to communicate over the internet, your access point or your router has a public IP address. So all the traffic is routed through this one public IP address over to the internet. Devices on your private network use NAT to share this public IP. So NAT is network address translation. What does this mean? This means that, let's suppose this is your router and you have these multiple client devices. So these all have private IP addresses. Let's suppose this one has 10.6.1.5 and this one has 10.6.1.6. And these are connected to this router, and this router is connected to the internet. And this router has a public IP address, let's suppose 200.4.3.1. So when a client wants to access the internet, the request comes to the router. The router then translates this IP address to this. So the request is forwarded to this IP address. It is basically translated. You can say that this is the source address translation. So the source IP is this, but it is translated into this public IP address. And how does router remember that since multiple clients are accessing the internet and there is only one public IP address? So here comes the port number. So for this client, the router associates this with a port number, let's suppose 45,550. So this is the port number, and for this there will be another port 45,551. So it remembers the request and sessions using the port addresses. Next is IPv6 addressing. So IPv6 as compared to IPv4, it is 1 to 8 bit long and it is in hexadecimal format. So this is a format of IPv6. So if you count all these bits, they will be equal to 1 to 8 bits. So benefit is that it solves the IPv4 address exhaustion. And the total number of IPv6 addresses are, if you calculate this, these are 340 trillion. I even don't know this number. So there is a huge number and they can be used and they are sufficient for foreseeable future. Another is that it has built-in features, so we no longer use or we no longer need the network address translation because this net was used due to limited number of IPv4 addresses. Now since we have a lot of these addresses, we no longer need the net and it is not used inside the IPv6 and it is auto configurable. So IP address are automatically assigned to the interfaces and it has built-in security. So security features that we will study in the coming lectures, such as IP stack, that is IP security, these are built in inside IPv6 and its prefix is like this prefix. When you see this prefix, it means that this is for local networking or for local communication. Another concept is the automatic private IP addressing, also known as APIPA. So this is basically used when DHCP server is unreachable or when it fails. So for example, you have a client and you want that this client can or this client is assigned an IP address through DHCP or dynamically. So the client requests the DHCP server, but the DHCP server is unavailable due to any reason or cannot assign IP address to this client. So here the client is automatically assigned an IP address in this range. Who assigns this IP address? It is automatically assigned by the operating system. So if you are using Windows laptop, it will get an IP address in this range automatically. And the range is 169.254.0.1 up to 169.254.255.254. So if there are multiple clients and all these clients cannot get the IP address, they all are assigned IP addresses from this range and then they can talk locally through these IP addresses but cannot access the internet or cannot talk to the internet services. Another concept is the static and dynamic IP addresses. So the static is when you assign a static or manually IP address to your device. So these IP addresses are manually configured on each device and they require careful planning to avoid IP address conflicts. So this means that you should carefully plan so that you don't assign same IP address to multiple devices. And if you do this conflict, if you assign multiple devices same IP address, they won't be able to communicate over the network, and the network will also be congested and performance will be degraded. So it is suitable for devices that need a consistent IP address such as printers. While on the other hand, dynamic IP addresses are assigned to the clients through DHCP. So devices obtain IP address automatically from a DHCP server. We have studied this multiple times. It simplifies network administration and reduces configuration errors. The most common method for client devices in SOHO networks, such as inside your home, you have the access points such as a Wi-Fi router, and your devices automatically get IP addresses from this access point through DHCP. Another concept inside IP addressing is the subnet mask. So this is the thing is known as the subnet mask, the IP address, and then you write the subnet mask that defines the range of this IP address. So it defines the size or the range of the network. Common subnet mask of class C that we use inside our home, such as with these IP addresses, is 255.255.255.0. It is suitable for smaller network, and it has up to 254 IP addresses. It helps determine. So another concept in IP addressing is subnet mask. So it defines basically the size of the network, and a common subnet mask that we use inside our homes, inside our private network is 255.255.255.0, which is basically a class C network. And we use this with these addresses commonly, such as 192.168.1.0 or 1.10. So with this IP, this is class C network, we use these subnet masks. It helps devices determine if destination is local or remote. What does this mean? This means that if, let's suppose, you have this IP address and this subnet mask, and let's suppose you want to send traffic to another IP address such as 192.168.1.5. So this device now knows that this IP address is in the same network, and it can send the traffic locally using or through switch, or in it does not require a router to send traffic because they are in the same network. Let's suppose there was another IP address 192.168.100.5. So now these two IP addresses, this and this, are in different networks. If the subnet mask is same, this network then ranges from 192.168.1.3 up to 192.168.1.254. So this IP is out of this range. It means that this is a remote network, and then we need a layer 3 device or router to reach a remote or a different network. Another important concept, default gateway. So it is the IP address of the device, usually the router, that allows a local network to communicate with other network, for example, the internet. So devices send traffic destined for outside local network to the gateway, and it must be correctly configured for internet access. So let's have a look over here. So here, let's suppose this is your PC IP address setting. So you have this IP address, the subnet mask, and this gateway. So what does this mean? This means that this router has basically this IP address, and you are telling your PC that you should send all your traffic to this gateway. As if you look at the terminology, default gateway, this is your default door or your default route or your default gateway to all traffic outside your network interface. So any type of traffic that it wants to send, whether it is local or whether it is to the internet, it will be sent to this router or to its default gateway. So this is a sample small office, home office configuration. So the router or the gateway has basically an IP address as we saw in the previous example. This IP address is used as a default gateway by all the clients. So this is the router interface as we saw in the previous example. This Soho router configuration or web interface. So this is router IP. It will act as a default gateway as well as a DHCP server for all the client inside the LAN. And you can define the DHCP range, such as here the start IP is 192.168.100 and the last or the end IP is 192.168.149. It means that the clients will get IP addresses from this range, and so a total of 50 clients can be given the IP addresses through this DHCP range. Remember, we called this as DHCP scope in our previous slides. So again, we will have the subnet mask of this 255.255.255.0, and the DNS server can be your router, or you can use an external DNS such as 8.8.8. You can give the DNS IP addresses. So this is a public DNS server from Google. You can use it inside your clients. You can define this. This is one. Another Google public DNS server is 8.8.4. So you can manually configure them over here as well. So summary of the Soho IP addressing. So IPv4 is the standard that has been used, but IPv6 is gradually going, and IPv4 is gradually replaced by IPv6. So the private IP addresses are basically used inside your local Soho networks or inside the LAN. DHCP assigns dynamic IP addresses to the client, while static IP address is manually configured. Subnet mask plus gateway basically control the traffic flow. If your IP addresses are in the same network, then the clients can communicate inside the same network. If the network is remote, then your traffic is sent to the gateway, and then the gateway then sends this traffic to the internet. A PIPA is used when your DHCP server fails or when client fails to get IP address from DHCP dynamically. It is assigned an IP address in this range by the operating system. So if all these clients cannot get IP address from DHCP server, let's suppose, they are assigned this IP address in this range, and then they can communicate locally over the LAN. Objective 2.7, compare and contrast internet connection types, network types, and their characteristics. So the first topic is in the internet connection type is the satellite internet connection. So the satellite internet basically uses satellites that are orbiting the Earth to transmit and receive data. So it is basically crucial for availability of internet in rural and remote areas where wired options are limited, such as in mountainous areas. Higher latency or delay, the satellite internet has higher latency, or you can say the delay compared to wired connection. Why? There are multiple reasons. First, the distance is huge, and secondly, there are interference in the atmosphere, such as you can say the clouds, the dust, the other things that increases the delay. In wired connection, you have no such delay because the traffic moves through the wire. There are delay, but not as much as in the satellite internet. And the speed of internet can vary, but generally slower than the fiber or cable internet. And the most popular satellite internet nowadays, if you see at this device, is from the Elon Musk Starlink. which is a revolutionary satellite internet, and it is expanding to multiple countries. It is now available in many countries and gradually expanding to other countries as well. So it offers a very high speed internet, and you can use it anywhere, anytime. Another internet connection type is the optical fiber, and this uses the thin strands of glass or plastic to transmit data as light pulses. So it offers very high speeds in gigabits and beyond, and it has a very low latency as compared to the Ethernet or copper or satellite internet. So the OFC, you can say, it offers the highest internet speeds. It is more reliable and less susceptible to interference than copper-based technology. So the copper, such as this Cat6, they are susceptible to interference from electrical signals, while the fiber, since it uses light, it is not susceptible to electrical interference. And its availability is still expanding, but nowadays in modern time, it is almost available to every home in urban areas and to every office. The latest modern ISPs basically provide you the internet connectivity through fiber inside your home, which is known as FTTH, as we already studied, fiber to the home. Next is the cable. So it uses the same coaxial cable that deliver your cable television through this type of cable. So it offers relatively higher download speeds, but upload speeds are often lower. And it works on the shared bandwidth with other users in the area, which can affect speeds during peak times. So if there are congested populated area and many users are using the same shared bandwidth, so the speed will be low, specifically during peak usage time. And it is widely available in many residential areas. Next is the DSL, or digital subscriber lines. So this was also used 2 or 3 decades ago. It is also relatively old and is being replaced by the optical fiber. So it uses the existing copper telephone lines to transmit data. By this connector, you can guess it is the RJ11 connector that was used inside your telephones. So you can use this ADSL modem and your existing telephone lines to access the internet. Speed and availability depends on the distance from provider's central office. So if the central office, ISP central office is far, speed will be used, it will be low, and if it is near, so speed will be high. And it has various types, as we already studied, such as ADSL and VDSL, and each offer different speed. And it is slower as compared to fiber or cable, especially if your location is further from the central office or from the ISP. Another type, emerging type in the 5G and 4G era, is the cellular internet. So it uses mobile phone networks such as 3G, 4G, LTE, and 5G to provide internet access. It is convenient for mobile devices such as your tablets and smartphones and areas with limited Wi-Fi options. Speed and data allowances can vary based on the service plan and network congestion. So latency again can be higher than wired connection because again it is wireless and there are multiple interferences inside the base that can affect its speed. Another internet connection type is the wireless ISP or WISP. So this basically provides internet access wirelessly using radio waves from towers to antennas at the customer location. So it is just like the cellular, but it is different from the cellular. If you have heard of WiMAX, so it works such that there is an antenna at the customer premises, and these antenna basically transmit and receive data to this customer antenna, and this customer antenna then delivers internet to other, let's suppose this is a switch, and other client devices can then use internet through this wireless connection. It often serves rural or underserved areas where wide options are limited, and speed and reliability can be affected again by weather and distance. So now coming over to some network types. So the networks can be defined by size, scope, and function. They can be smaller, such as LAN, or huge or larger, such as WAN, and specialized network for personal or storage or for storage use that we will study in upcoming slides. So the first network and the smallest you can say is the PAN, also known as the personal area network, and this is the network that is used for the Bluetooth connectivity, or if you say, you can say the wired example of PAN is the USB connection, which is in about which have about 1 meter range. Bluetooth maybe may have up to 10-meter range. So this is your personal area network that you use inside your, you can say, your room or your home. Another greater network with respect to size is the LAN, which is the local area network, which you use inside home or offices network, such as this one, which uses the Cat6 cable, and it has a greater range of up to 100 meters, which can also be increased if you use multiple switches or multiple routers. Next one is the wireless LAN. So it is similar to this one, but this is wireless. It uses access points like this one, and commonly it is used. It uses the IEEE 802.11 standards, such as Wi-Fi 5, Wi-Fi 6, etc. And then, so we are going from smaller to larger network. The next network which spans about a complete city is the MAN, which is Metropolitan Area Network. And it is a citywide, or you can also say it can be used in a big campus networks. And even larger than the MAN is the WAN, which is the wide area network, which spans countries, cities, or even the whole world. And the largest of the WAN is basically the internet. So it connects LANs all over the long distances and all over the world. The largest WAN in the world is the internet. There can be other WAN by the organization. They can have private WANs as well. But popular example of WAN and the largest WAN is the internet. A specialized network is the SAN, which is storage area network. So it is a high-speed storage network for servers. For example, this may be your storage inside your organization, which basically have multiple disks, and it has the availability capacity, and it provides storage capacity in terabytes and in petabytes, and the servers basically access this storage from this central location. So now coming over to comparison of these different network types. So span, if we compare, the range is the smallest of all. It is equal to or less than 10 meters. Speed is slow. If you have used the Bluetooth data transfer or connectivity, so its speed is slow. An example is the Bluetooth headphone or transferring data between smartphone or Bluetooth. Next is the LAN. So LAN has a range of less than 1 kilometer. Speed is 1 gigabit plus 1 gigabit per second plus. So as we already studied that Wi-Fi 6 has up to 9.6 gigabit per second. And its example is your office Ethernet or your home LAN or home Ethernet. Next is WAN, which its range is global up to 100 and 1000 of kilometers. Speed may vary depending upon your ISP connection or the connection you are using. If you are using OFC or FTTH, your speed may be high. If you are using the DSL or copper lines, your speed may be low. An example of WAN is the internet, and then again the same. It range is basically the data center that an organization is using. Data center may spans up to a building. You can say roughly that it's is up to few meter. You can say 10 meter, 20 meter. Its range is because it uses OFC cables and it is used inside the data center. Its speed is 10 gigabit per second plus, and its example are NAS. NAS is network attached storage or enterprise storage. So our last objective, objective 2.a of this domain, is explain networking tools and their purposes. And the first tool is the crimper. So it basically attaches RJ45 connectors to the Ethernet cables, such as this one. It compresses pins into the wire pairs, and it is used to make custom cables. What does this mean? So we have prepaid Ethernet cables of different lengths, such as 5 meter, 10 meter. Let's suppose you need a Ethernet cable of 70 meters, so you can get a 70 meter Ethernet cable and attach RJ45 connector on both its ends using this crimper tool. Next is the cable stripper. So it removes outer insulation layer from this Cat6 or Cat7 cable, and it prevents, it exposes the twisted pair cables such as these one, and it prevents wire damage. It prevents damage to the internal wires. Next is the Wi-Fi analyzer. So it may be a software based, such as a software that you have installed inside your laptop, or it may have a Wi-Fi analyzer, maybe a hardware specialized tool that scans the wireless environment. And the display of this analyzer basically displays nearby Wi-Fi networks, and it displays this information such as the SSID of the network, the signal strength, the channels, and the security type used by the Wi-Fi networks. And this Wi-Fi analyzer is basically used to identify congestion, interference, and optimal channel selection, as discussed in the wireless networking. Another tool is the toner probe kit. So what is this? So it is a two-part tool, part 1 and part 2, to identify specific cables within a bundle. So how does this work? So the toner, that is the tone generator, sends an electric signal down the cable. It is basically this one is the sender. So you attach cable over here to this part and it sends a signal. And the probe, this one, so this one is the probe. So the probe or the inductive amplifier emits a tone when near a cable carrying the signal, this one. So this also emits a tone when near a cable carrying the signal. So it is useful for tracing cables in walls, ceilings, or page panel without physically following them. So I hope you get the point. So you send signals through this device by attaching a cable to it, and then you go with this device, you press this button, and then it will show that where is the strongest signal. So at the end of the cable you will get the strongest signal, and you will know that where this cable ends or where this cable goes. Another tool is the punch down tool. So it inserts wires into page panel or keystone jack. Remember, we studied the page panel. At the back of the page panel, we insert these cables inside the page panel using this punch down tool. And it can also be used to cut excess wires while seating it into these places. It ensures tight connection with insulation displacement. Another popular tool used by a network technician is the cable tester. So it is used to check the continuity and the wiring order of the network cable. specifically the Ethernet cables. So it can identify common issues in the patch cards or the cables, such as open circuits, it means the broken wires, short circuits, wires incorrectly connected, and cross pairs wires in the wrong order. So it has all these wires number 1, 2, 3, 4 up to 8, and it can show you the if the order is wrong, if there is short circuit, and etc. So it has two ends. You connect one end at the one part of the tester and other end at the other part, and then you press the button, the test button, and then it gives you the detail of the cable. If it is good, it will show you the result. If there is some issue, it will indicate the issue. And it is essential for ensuring proper cable termination and network connectivity. Another important tool, it is a small tool but important to test connectivity and test network card, is the loopback plug. So it is basically a simple connector used to test the functionality of a network interface card. It is basically, you can say, an RJ45 connector that is loop-backed inside to test your, you can say, different network interface cards. It physically connects the transmit pins of a port to its receive ports pins. So the transmit pins and the receive pins are basically connected and looped back. So when you connect this to a port, if the port blinks and becomes up, it means the ports is working, because the ports then sees that traffic is coming, it receives and transmits the packets through this loopback cable. So it allows you to send data out of the NIC and have it immediately loop back in, verifying the NIC's basic operation and functionality. So this is for Ethernet cable or for RJ45 connector. To test RJ45 cards, this one can be used to test the fiber interfaces. This is fiber loopback plug. Another tool is the network tap. So it is a hardware device that allows you to intercept and monitor network traffic without interrupting communication flow. So it creates a copy of the network traffic that can be sent to the analysis tool, for example, packet sniffer. It is passive and non-intrusive and ensuring no impact on live network traffic. So how does this work? So basically, let's suppose you have a switch over here and it has multiple ports connected to different lines. Also, let's suppose connected to the internet. So you can configure one port, and you can configure it such that all data that is received or all the ports is sent to this port. And then you again take another cable out from this port and connect it with a packet analyzer. Let's suppose this is a laptop and you have Wireshark, which is a tool to inspect network traffic. You have a Wireshark installed over here. So here you can monitor and you can analyze all the network traffic, because all the network traffic is copied to this port over here and then it is replicated to this device. So this is how this network tap works. So the summary of the networking tools and for which and what purpose they are used. So to build network, you need the crimper, which is this tool to connect these RJ45 connector to the cables. Stripper is used to strip this out layer of the cable, and punch down tool, as we studied, is used to punch the cable at the back of the patch panel. To trace the cable, you need toner probe tool. For testing different network or cable, you for RJ45 you can use this testing tool, cable tester, as we studied, or for the network interface cards you can use the loopback plug. To analyze network, for wireless network, Wi-Fi network, you can use the Wi-Fi analyzer, and for the wired network or Ethernet network, you can use the network tab. So that's all for this domain. Thank you for your support. Thank you for watching the video. So please subscribe, like and share the video, and stay tuned for the next domain. Welcome to the domain 3 of our CompTIA A Plus course, hardware. And our first objective 3.1 is compare and contrast display components and their attributes. An introduction to the display technology. So displays are essential for visualizing the computer output, such as in the form of monitors. Various technologies offer advantages and disadvantages, and in this particular session we will focus on common display types, including the LCD, OLED and mini LED. So understanding the display technologies and their attributes is crucial for their troubleshooting as well as upgrades. So first of all, let's go through some display attributes, and the first attribute is the pixel density or PPI. So PPI is the pixel per inch, and the higher the PPI, the sharper are the images. So if there are more pixels on a particular size of the screen, the image will be sharper, such as in this case, this image has a 300 ppi and the image is clear and sharper, and the same image when shown in less 72 ppi, we can see there is less detail and the image is not sharper as this one. So the ppi basically affects clarity as well as detail. The next attribute is the refresh rate, which is measured in hertz. Some common refresh rates are 60 Hz and 120 Hz. And refresh rate basically shows how often images are updated per second. So 120 means that 120 images can be updated per second. So the higher the refresh rate, the smoother is the motion inside the display. Next attribute is the screen resolution, which is the total number of pixels commonly shown in this format, such as 1920 into 1080. So the more pixel is equal to higher or more detail. The more are the pixel in a certain display or at a certain area, the higher will be detail in the image, as we already studied. So resolution and screen size together determine pixel density. So if we have a higher resolution and a lower screen size, we will have a very high pixel density. And the last attribute is the color gamut, which is the range of colors a screen can show. So a wider gamut means richer and more vivid colors. So the common types include the sRGB, Adobe RGB, and DCI-B3. So our first display type is the LCD, that is liquid crystal display. So this display type or the LCD uses liquid crystals plus backlight to operate, and it is common in monitors, laptops and budget TVs. So LCD is energy efficient and affordable, and its subtypes include IPS, TN and VA. So we will study these the next slide, including their what does these abbreviation mean. So the LCD subtypes include, the first one is the IPS, that is in plane switching. So it shows best color and accuracy, that is viewing angles, but the response time is low. Next is the TN, that is twisted pneumatic. So it has a fast response time, and which means that it can be used for gaming where we need a very fast response time, but it has poor viewing angles and color. So we can see that these two are at odds with each other. This one has fast response time while the IPS has slow response time. but the viewing angles and colors are poor in TN, while same are good and viewing angles are best in IPS. So when choosing, you will see your requirement and then you can decide which type of display is best for you. For example, if you are a gamer, then you will select TN or twisted pneumatic. Next is the VA, that is vertical alignment, and this one has a higher contrast, but the response time is slower than TN. So our next display type is the organic light emitting diode, that is OLED, and in this display type each pixel is self-emissive, that is it generates its own light, and its advantages include that it has incredible contrast ratio, also known as true blacks. The colors are vibrant and accurate, and it has again very fast response time, which is required for gaming, and again it has wide viewing angles and it can be made very thin and flexible. So it has many advantages that were not available in LCD subtypes, but its disadvantages include that it can be more expensive to manufacture. So LCD were budget types, but this one is more expensive. So it has a potential for burn-in, though technology is improving. So burn-in means that when you display static images on screen for a very long time, these images can stick to the display temporarily or permanent. So brightness might not be as high as in some LCDs. So next one is the mini light emitting diode, that is mini LED. So this one uses thousands of tiny LEDs as the backlight for an LCD. So it means it uses an LCD, but for the backlight, tiny LEDs are used. So it allows for more precise local dimming. Its advantages include that it has improved contrast ratios compared to traditional LED backlit LCDs. It has increased brightness. It has better HDR, that is higher dynamic range performance, and it can be more energy efficient than OLED in some scenarios. Disadvantages include that it still relies on an LCD layer. It means that this LED, mini LED, is not self-emissive. It relies on LCD layer. It can be more expensive than traditional LED LCDs, and it may exhibit some blooming. So what does blooming mean? That light bleed around bright objects. So now coming over to the touch screen or digitizers. So the touch screen basically allow user interaction through physical touch, and digitizer converts touch input into digital signals, and it is common in laptops, tablets, and smartphones. So different technology exists for touch detection. So touch technologies overview. So different touch technologies are available in the market. One of those is the capacitive. So the capacitive basically relies on the electrical properties of the human body. So it is most common for the multi-touch. Next one is the resistive. So layers of material respond to pressure. So this was the older technology that was used in smartphone, where you have to push the screen a little bit, apply some force, as we can see here, and it was often single touch. So the older smartphone display types were resistive and they were single touch. Nowadays the displays are mostly capacitive and they are multi-touch. Next touch display type is the infrared, where sensors detect break-in infrared beams. So there are infrared beams over the display, and when you touch this, the pattern is disturbed and a touch signal is produced. Next one is the surface acoustic wave, that is SAW. So this is ultrasonic. In this form, ultrasonic wave detect touch. So both these here, infrared is used to detect touch, while in the surface acoustic wave, the ultrasonic waves detect the touch. So conclusion, touchscreens and digitizer enable direct interaction with the display. So inverters powered older LCD backlights, pixel density, refresh rate, resolution, and color gamut significantly impact display quality. So these are some of the display attributes. And knowledge of these components and attributes is vital for your CompTIA A Plus exam, as well as for your professional field being a technician. Our next objective 3.2 is summarize the basic cable types and their connectors, features, and purposes. So introduction to cable types. So cables are essential for data transfer as well as connectivity, and different types of cable are designed for different applications. So in this session we will cover network and peripheral cables. Understanding the characteristics of these cables is crucial during their troubleshooting. So first of all, some common copper network cables, and the first one and the most popular one I can say is the unshielded twisted pair, that is UTP, and it is commonly used inside offices in your LAN local area network. And the common types include the Cat5e, the Cat6, and as we can see, it is called the unshielded twisted pair. So these are the twisted pair. These are two cables. So there are four pairs, and the total number of cables are 8. So when we say unshielded, we mean that these pairs have no extra shielding. Beside this plastic covering, there is no protective shield over these individual pairs. The next one is the shielded twisted pair, and as contrast to this one, here we can see there is an additional shield over these twisted pairs. That's why this one is known as shielded twisted pair. And this extra shield basically reduce interference and increase the distance as well as the speed of these cables. And this is commonly used in industrial usage. So this was commonly used inside offices at homes, while this is for industrial usage. Next one is the coaxial cable. So we are talking about copper cables, and this one is an older technology that was used in cable TVs and also used by some internet service provider in older times. Nowadays, even ISPs are using optical fiber directly to our homes in the form of FTTH, that is fiber to the home, which we already studied in our last session of networking. So now some Ethernet cable categories, and the first one is that we already studied is the Cat5e. This one is now phased out by the latest categories, and it has the rate of 1 gigabit per second. It can run up to maximum of 100-meter length. So after 100 meters, then you need to install a switch, a hub, or a repeater, you can say, that then regenerate the signal, and then you can again run this cable for another 100 meters. The next one is the Cat6, which can say the upgraded version of Cat5. So it can have a speed of up to 10 gigabit per second. but its length is less than Cat5e and it can run up to 55 meters. So you can say that this one can be used inside data center for the servers connectivity, while this one is basically used for client connectivity inside our lanes in offices as well as in homes. And the latest one is the Cat 6a or also Cat 7, and this one has even higher speed than Cat 6, and it is because it has better shielding. So for Cat 7 or Cat 6a, this extra shielding is essential. So this is optional over here, or you can say over here, but for Cat 7, this extra shielded shield over the twisted pair is essential, and without this you cannot achieve such higher speeds, even higher than the 10 gigabit per second. So in other words, you can say that Cat 7 is always STP, that is shielded twisted pair. So what are the T568A versus T568B wiring standards? So these both standards basically they are used for RJ45 connectors, and T56B is more common in the United States, and the pattern must match on both ends, or you can use the crossover. So what does this mean? This means that as we studied, the Cat 6, Cat 7, Cat 5, they has 8 cables, and when you connect these cable to the RJ45 connector, it must be connected to some pattern such as this one. These cables are basically, the individual cables are colored. So this pattern, when you connect these cable in this sequence, this is known as T568A, while this sequence is known as T568B, and this one is most common in the United States. So our next topic is the plenum rated network cable. So what are those? So these are special jacket material designed to be fire resistant and produced minimal smoke. So this outer layer, this is basically fire resistant, so fire cannot damage these cables. And connector type are typically RJ45, because as we can see, these are the Ethernet cables. For plenum related twisted pair cable, we use the RJ45 connectors, and their features include that there are safety requirements for cable run in plenum spaces, that is above ceiling, under raised floors, and that are used for air circulation. So the purpose is that these cables ensure safer air quality in the case of fire. So our next topic is the network cable but optical fiber cables. So these transmits data as light pulses through glass or plastic fibers. So previously we discussed the copper cables. Now the fiber cable, optical fiber, they basically use light as a source, while the copper use electricity as a source. And the connector types, common connector types include LC, SC, ST, MTP. So we will study these in details in the upcoming slides. So these are the common connector. This is SC. SC stands for subscriber connector, but some people also call it square connector because this connector is in the form of square. This one is lucent connector, LC. So this is a little thin, and for remembering, you can also say this is a long connector, as we can see. This one is ST, also known as straight tip connector. So these are the older ones, these two, and these are the latest. FC is the ferrule connector, and then the MTP. So this one is used as a output of multiple fiber cable. So if we have multiple fiber cable, let's suppose 10G, 10G optical fiber connectivity, these all can be terminated as a single connector, and that connector is known as MTP. So the optical fibers are of two types. One is single mode. So the single mode has a thin core and it is used for longer distances in kilometers, and it has a higher bandwidth. Next one is the multi-mode fiber, which has a thick core, and it is used for shorter distances, usually less than 100 meters inside data centers, and it has lower cost as compared to single mode. And the features of the optical fiber are that they has very higher bandwidth, and they are immune to electromagnetic interference. So the copper cable were not immune to EMI. That's why we use those shielding to protect against EMI. The optical fiber does not need those extra shielding because it is immune to EMI. So the purpose of the using the optical fiber is for high speed networking. They are used for higher distances. So as we saw that the Cat6, Cat5, they can run up to 100 meter at max. So for a distance where we need where we have the requirement of longer distances, such as between cities and even between countries, where the cable run for 100 and 1000 of kilometers, we need optical fiber because they have the capacity to run over 100 and 1000 of kilometers. So our next cable type is the peripheral cable, and that is USB 2.0. So USB is the universal serial bus standard, and the connector type include type A, which is this one, type B, mini B, micro B, which are various physical connector types. We will study these in the upcoming slides. And the feature include that it has a maximum data transfer rate of 480 megabit per second. So this is an older version, USB 2.0. It has a slower speed. The newer version 3.0 has a greater speed than this one. And the purpose of the USB cables are to connect various peripherals such as mice, keyboards, printers, external drives, and older devices. So next is the USB 3.0 and upward or onward, and it has a super speed USB and beyond. So connector type include again type A, such as this one, but often in blue color, type B, micro B, type C with additional pins and design. And features include significantly faster data transfer rate. So USB 3.0 can have data rate of up to 5 gigabit per second, USB 3.1 up to 10 gigabit per second, 3.2 up to 20 gigabit per second, and USB 4 up to 40 gigabit per second. And the purpose of using USB 3.0 is for high-speed data transfer for external drives, video, and other demanding peripherals. USB-C also supports power delivery and alternate modes. Another cable type in peripheral cables is the serial. So it was used for older communication types, and it is an older communication interface, and it transmits data serially, that is 1 bit at a time. That's why it is known as serial. So the connector type is DB9, that is 9-pin D sub miniature, this one. So here we can see we have 9 pins, and this is 9-pin connect. So this is the male connector and this is the female connector type. And features include that it is simple, reliable for low speed communication over short distances. So the network guy or even the system guy must know that this connector is used for configuring the network devices through serial connection. And the purpose is to connecting older peripheral, modem, some printers are connected through these cable types. industrial equipment, embedded system, and to configure network and system servers. Now coming over to video and hard drive cables. So there are specific cables for transmitting video signals. So dedicated cable for connecting storage devices. Understanding their capabilities is essential for system setup and troubleshooting. In video cable, the first one is the HDMI. So it is common in TVs, monitors, and gaming consoles, and it supports audio as well as video up to 8K with 60 Hz refresh rate, supported by HDMI 2.1. So the crucial thing to remember is that it supports both audio as well as video. Next one is the DPR display port. So it is preferred for PCs and a higher refresh monitor, and it supports daisy chaining where multiple monitors are connected with each other. Next video cable or interface type is the VGA. So it is analog only and it is of lower quality, and it is being phased out because it is very old technology and it has a 15-pin connector. And the next is the DVI. So it supports both digital and analog, and it has two types, or it can say its variations are DVI-D, which is digital only, while DVI-I, it supports both digital as well as analog. And this one is also mostly replaced by HDMI and display port. So we can say that the previous two ones, the HDMI and DP or display port, are the latest technology, while the DVI and VGA are being phased out. And our last video cable type is the USB-C. So it carries video, data, as well as power. You can say it is all in one. It supports DisplayPort, HDMI, used through alternate mode, and it is used commonly in phones, laptops, and docks. So it is the latest standard and most commonly used nowadays for transferring of data from your smartphone as well as charging them. So now coming over to hard drive cables, and the first one is the SATA. So it connects internal storage, that is it may be the hard disk drive or the SSD, and its connector is this slim 7-pin connector such as this one. These are 7 pins, and it can transfer data of up to 6 gigabit per second by the SATA 3 variant. Next one is the eSATA, which is external version of SATA, and it is faster than USB 2.0 but requires separate power source, and it is largely replaced by USB 3.0 plus. So now coming over to introduction of adapters and connectors. So adapters allow different interfaces to connect. Connectors are physical interfaces for cables and devices, and recognizing them is crucial for compatibility as well as troubleshooting. So first of all, let's go through some network connectors, and the first one is our popular and beloved RJ45, and as we studied, it is used for to connect Ethernet cables such as Cat5, Cat6, and Cat7. Next one is the RJ11, and as we can see, it is similar to RJ45 but a smaller, is much smaller, and it is used in older telephones 6P4C. And next one is the F type, which is coaxial cable used in cable TV and modems, and this is basically connects copper coaxial cable. So now coming over to optical fiber or fiber optic connectors, and first one is the ST, which is straight tip connector. So it is a bayonet style older connector which was used in older installations. So we can say that this is also being phased out by the latest LC and SC connectors. So the SC, it is square push pull connector and it is commonly used inside data centers. Next one and the most common one is the LC connector. You can say it is Lucent or also spelled as long connector by some. So this is small form factor used in modern networks. What does this mean? So in modern network, we have these switches and these switches has optical fiber interfaces. In these interfaces, we first insert small form factor pluggables, also known as SFP, and inside SFP, when they connect, then connect these connectors. So these are two connectors. Basically, one is for receiving, you can say RX, and other is for transmitting data, that is TX. So this is used to connect the networks inside data center as well as the customer premises. So now coming over to some USB connector evolution, and the first one is the USB type A. So it is standard host connector. Next one is the micro USB. We also studied this in our initial session. So this was used in older Android devices, and in even older one is the mini USB, which was used in legacy cameras as well as some other devices. The latest standard nowadays that is used is the USB-C. So it is modern universal standard and the Apple proprietary Lightning. So this Lightning or Apple proprietary connector is also being phased out by the USB-C. If you people know, Apple was forced by the EU through regulation to use USB-C connector for their smartphones and other devices as a universal standard. So in the modern Apple iPhones, the Lightning connector is no longer used. Apple is also changing to USB-C. So some specialized connectors and DB9 RS232, we already studied this one. So it is used for serial consoles and in legacy industrial systems. Next one is the Molex, which is a 4-pin power supply unit used for peripheral power. And the punch down block, so it is network terminations 110 block. So here we can see the Ethernet cable Cat6, Cat5 are basically terminated into these blocks, and from here onward we can connect through RJ45 patch cards to other host or network devices. So summary, so we have different connector types, VGA, which is used in legacy monitors, and it is replaced by the HDMI and USB-C. Mini USB, it was used in old cameras. It is also replaced by USB-C. So ST fiber is a optical fiber connector which was used in older installation, and it is used by the LC connector, Lucent or long connector. So now coming over to introduction to RAM, that is random access memory characteristics. So RAM is the volatile memory used for active data inside computers, servers, laptops. So various characteristics differentiate various RAM modules, and the form factor dictates physical size and pin count. So we will focus on SODIMM as well as DIMM. So we will study these in details in the upcoming slides. So RAM form factors, you can say in simple word, the form factor is basically the size, and we have two, the SODIMM and the DIMM. So the SODIMM, that is small outline dual inline memory module. It is basically a compact form factor, this one. So this one is compact than this one, which is the DIMM. DIMM, that is dual inline memory module, it is the standard size form factor that was used in our desktop PCs. So primary difference is in their size as well as the pin count, and they are designed for different types of systems. So now let's study the SODIMM, that is small outline dual inline memory module. So the size is smaller and more compact than DIMM, and the pin count is that it has fewer pin compared to DIMM, that is it may have 144, 200, 204 or 260 pins, and it is typically used in smaller devices such as laptops, notebooks, mini PCs, all in one computers, and even in some network devices. And it has the advantage of space saving design for portable and small form factor systems. Disadvantage is that it is generally not interchangeable with DIMM because both have different sizes as well as pin count. Next one is the DIMM, that is dual inline memory module. So it has a larger size than SODIMM, and the pin count is higher as compared to SODIMM. It has a pin count of 168, 184, 240 or 288, and it is typically used in personal desktop computers. And the advantage is that it is generally most cost effective per GB size as compared to the SODIMM, and it has a wider availability and has high performance options. So it has multiple higher performance options, and it is wider available. Disadvantage is that it is not suitable for space constrained systems such as laptops and mini PCs, etc. So now let's compare both these side by side. So the size in size, SODIMM is smaller, DIMM is larger, as we can see. This one SODIMM is smaller, this is DIMM, it is longer, larger. Pin count, SODIMM has fewer pin and DIMM has more pin. So you can count here the DIMM has more pin as compared to SO pin. And use cases is that SODIMM is used for smaller portable system while DIMM is used for larger desktop systems. Interchangeably, so they are not interchangeable due to physical and electrical differences. And the cost factor is that SODIMM are often more expensive per GB as compared to the DIMM. Well, as well the performance is concerned, performance capability can be similar within the same generation, for example DDR4, but higher end option might be more readily available in DIMM. Double data rate, that is DDR iterations. So DDR or double data rate technology allows RAM to transfer data twice per clock cycle. Successive generations offer increased speed, lower voltage, and higher bandwidth. So key iterations of DDRs include DDR or DDR1, which is the original DDR SDRAM type. DDR2 gives faster speeds, lower power consumption than the DDR first generation. DDR3 has further increased the speeds. It requires lower voltages than DDR2. And then subsequently, DDR4 has even higher speed and lower voltage than DDR3 and increased density. DDR5 significantly have higher speeds and bandwidth than DDR4, and it consumes lower voltages, and these trends continue onwards. Now coming over to ECC versus non-ECC RAM. So what are these two type of RAM types? So ECC RAM basically detects and corrects bits errors, and it is used in servers and higher end workstations, and it is more expensive than non-ECC RAM. So here we can see that ECC RAM has 9 memory chip as compared to non-ECC RAM which has 8 memory chip. And this extra chip, the 9th chip, is basically used for error detection and correction. Non-ECC RAM, it is used in consumer grade PCs, and it does not has the error correction or detection capability, and it is less costly and more affordable as compared to ECC RAM. Next is the RAM channel configuration. So channel is basically the communication path between the RAM and the CPU. So it is how RAM modules are installed to increase memory bandwidth. So if you have one channel, you will have less bandwidth as compared to dual channel where we have two communication channel and thus higher bandwidth. So common configuration of RAM channel include single channel as this one, dual channel as we can see in this where we have two communication path, quad channel, hexa channel and octa channel which has 8, 7 and 4 communication paths. So it requires that a motherboard support these channel configuration and modules should ideally be identical for optimal performance. What does this? This means that the RAM modules that are installed in different channel configuration must be identical. Next is the single and dual channel RAM configuration. So in single channel, there is only one communication path between the RAM and CPU, and it gives the base performance such as this one. In the dual channel, there are two communication pathways, effectively doubling the memory bandwidth. It has significant performance improvement over the single channel. And implementation can be done by installing matching RAM module in the correctly colored slots on the motherboard. So you must refer the manufacturer motherboard manual when configuring these channels on the motherboard by installing the RAM module in the correct slots. So what are then quad channel RAM configuration and beyond? So quad channel gives us 4 communication pathways between the RAM and the CPU, further increasing the bandwidth, and it is common on higher end desktop platform. Hexa and octa channel gives even more pathways, 6 and 8 channel pathways, and it's found on enthusiast and server platform, and it gives us the maximum memory bandwidth. Implementation can be done through specific motherboard configuration and installing the matching RAM module in the designated slots by referring to the manufacturer motherboard manual. Now coming over to HDDs or hard drives. So these are magnetic storage devices with spinning platters. So data is read and written by read-write heads such as this one. And key characteristics include that spindle speed and form factor. So this is basically the spindle, and form factor is the size of the HDD. So these are generally more affordable per gigabyte than SSD. SSDs are costly and as compared to HDDs. So similarly, they are slower. They have slower access time and more susceptible to physical damage compared to SSD because they have many mechanical and moving parts. So what are the hard drive spindle speeds? So these are the rotational speeds of the platter measured in revolution per minute or RPM. So common speeds are 5400 RPM, 7200 RPM, and 10,000 RPM, and even higher for enterprise solutions. High RPM generally means faster data access and transfer rates. So 5400 RPM are common in laptops, lower power consumption. It requires lower power, and these are slower speeds. 7200 RPM are common in desktop, and they balance the speed as well as the cost. while the 10,000 plus RPM gives us higher performance, and they are used in servers and some high-end desktop, and they require higher power and produce higher noise as well. So the hard drive or HDD form factor, so this is the physical size of the hard drive. So 2.5-inch form factor are the small form factor, and these are commonly used in laptops and some small form factor desktop, and they consume lower power as compared to 3.5-inch form factor. So this is 2.5-inch and this is 5-inch form factor HDDs. 3.5-inch HDDs are the larger form factor HDDs, and they are standardly used in the desktop computer, and they generally offer higher capacities and better performance per dollar compared to 2.5-inch. Now coming over to our next storage device type, which are the SSD or solid state drive. So these use flash memory to store data electronically, and they have no moving or mechanical part as opposed to HDDs. And the key characteristics include the communication interfaces, that how they connect their communication interfaces, and their sizes or form factor. So they have significantly faster access time and data transfer rate as compared to hard disk drives. And they are also more resistant to physical shock and vibration because they have no moving mechanical parts. But the downside is that they are generally more expensive per gigabyte than HDDs. So what are some communication interfaces used inside SSD or solid state drives? So the communication interfaces are how the SSD connects and communicates with the rest of the systems. And the first one is the SATA, that is Serial Advanced Technology Attachment. So these are the older interfaces commonly used inside 2.5-inch SSDs, and they are limited by SATA 3 version bandwidth, that is up to 6 gigabit per second. So that is the speed, or you can say bandwidth limit. Next is the NVMe, that is non-volatile memory express. So these are the higher performance interfaces designed specifically for SSDs. They utilize the PCIe bus for much higher bandwidth as compared to SATA. Next one is the PCIe, that is Peripheral Component Interconnect Express. This is the direct connection to the system's PCIe bus, offering very high speeds. So NVMe SSDs often use the PCIe interface. And the last one is the SAS, that is Serial Attached CASI. This is SAS. So these are primarily used in servers and high-end workstation, and they offer higher performance and reliability. What are some form factors of the SSD? So form factor are the physical size and connector type of the SSD. The first one is the 2.5-inch. So this is the standard form factor, and it uses the SATA interface typically, and it has easy drop-in replacement for 2.5-inch HDDs. What does this mean? This means that this 2.5-inch SSD can be easily replaced with the 2.5-inch HDDs, or you can also say that the 2.5-inch HDDs can be replaced by these 2.5-inch SSD. So there is this compatibility. Next is the M.2, which is small gumstick shaped form factor. This one, as you can see, this is gum shaped, and it can support SATA or NVMe, that is PCIe interfaces. So this is the interface where you can plug this in, and it offers higher performance potential and space saving. Next one is the M SATA, which is the mini SATA, and it is older small form factor SATA SSD. It is less common now often found in older laptop and embedded systems. So now let's compare some properties of the HHDs and SSDs. So as with regard to the speeds, the SSDs are significantly faster. They have faster access time and transfer rates. As with regard to cost, HDDs or hard disk drives are generally cheaper per gigabyte than SSDs. So SSDs are more resistant and durable to physical shock and as compared to HDDs. Since SSDs has no mechanical parts, they produce no noise as compared to HDDs. And similarly, in power consumption, SSDs generally consume less power as compared to HDDs. In capacity, HDDs traditionally offer larger capacity at lower prices. And in lifespan, SSD lifespan or write cycle is a consideration, but modern SSDs are very durable for typical use. Fragmentation is less of an issue for SSD. So we can see that SSD has more advantages over HDDs except the cost and the capacity. So this is again the comparison in table form. So HDDs has a typical speed of 100 to 200 Mbps, while SSD has larger speed from 500 up to 7000 Mbps. Durability, HDD has 3 to 5 years durability, while SSD has larger durability time period of up to 10 years. And in capacity, HDD has 20 terabyte plus capacity, while SSD has 8 terabyte capacity. When in the price, again, in this comparison feature, the HDD wins. It has up to $0.02 per GB, while the SSD is on the more expensive side, and it has a price of up to 8 cents per GB. So the conclusion is that considering the performance, speed, budget, and durability requirement when selecting between HDDs and SSDs. So SSDs are ideal for operating system and frequently accessed applications. Similarly, HDDs are suitable for mass storage where cost per gigabyte is a primary concern. And you can use hybrid system combining SSD and HDD to offer a balance between the cost and the speed. Our next topic is the driver configuration, that is RAID, redundant array of independent disks. So this configuration basically combines multiple physical drives into a single logical unit, and it offers benefits like increased performance, fault tolerance, or you can say redundancy, or both. So different RAID levels provide different. So RAID level 0, also known as striping. In this one, data is striped across multiple drives. As we can see, some data is on one drive and some is striped across another drive. And it has a benefit of increased read and write performance, but the drawback is that it provides no redundancy. So if one drive fails, it means all data is lost. So if any of these drive fails, it means that all data is lost because data is in parts striped across both these drives, and it requires at least two drives. Next is the RAID level 1, also known as mirroring. So here data is duplicated across two drives. So here we can see that same data is duplicated across two or multiple drives. So benefit is that it has excellent data redundancy. So if one drive fails, the other drive contains a complete copy. So here we can see that this drive has the complete copy of data on this drive. So if this one fails, we have complete data over here. Similarly, if this one fails, complete data is available on the alternate drive. And drawback is that it has reduced usable storage capacity because 50% of storage capacity is used by redundancy, or you can say that data is copies across, same data is copied across the other drive, so it requires double data storage requirement. Next, in the RAID level 5, that is striping with parity. So what does this mean? It means that data is striped across 3 or more drives. What does this mean? This means that we need at least 3 drives with parity information distributed across all drives. So we have parity information that is distributed across all drive, and this parity information is used to recover data if one drive is lost. Benefit is that it provides good balance between performance and redundancy. So it gives both the performance as well as redundancy, and it can withstand a single drive failure without data loss. And drawback is that it is more complex to implement. Write performance can be slightly slower due to parity calculation, and it requires minimum 3 drives to operate. And the next level is RAID level 6, also known as dual parity. So it is similar to RAID 5 but with 2 sets of parity information striped across 4 or more drives. Benefit is that it provides higher fault tolerance and it can withstand up to 2 simultaneous drive failures without data loss. And drawback is that it is again more complex. Write performance can be slower than RAID 5 due to the double parity calculation, and it requires at least 4 drives to implement. Next is the RAID level 10, that is 1 plus 0, which combines mirroring and striping. So this combines the benefit of RAID 1, which was simply mirroring, and RAID 0, which was simply striping. So it requires an even number of drives, that is minimal 4 drives. And benefit is that it has higher performance as well as excellent redundancy. Drawback is that it has reduced usable storage capacity, that is 50%, and it is more expensive due to number of drives required to implement. So here we can see that it is on the upper level, it is RAID 0, that is striping, while on the lower level the RAID 0 has 2 RAID 1 on each side, and RAID 1 is simply mirroring. So this is how it is implemented. It is RAID 0 plus RAID 1. Now coming over to removable storage flash drives. So these are small portable solid state storage drive. You must have used these drives, and they connect via the USB interfaces of your laptop computers. Features include they are easy to use, durable, relatively inexpensive for common capacities. And the purpose is that to transfer file between computers, portable backups, and for software installation. Next are the memory cards. So they are used in digital cameras, smartphones, tablets, and other portable devices, and they have various form factors such as SD, that is secure digital, micro SD, and compact flash. So these are different sizes. This one is, I think, SD, and this one is micro SD, and this one may be compact flash. Features include they are small, solid state, varying capacities, and have varying speed classes. And purpose is that they are used to store photos, videos, and other data for portable devices, and they often require a card reader for computer access. Optical drives. So these optical drive basically use lasers to read and sometimes write data to optical discs, such as this one. And common type of discs include the CD, which is compact disk that stores around 700 MB of data. DVD, that is digital versatile disk, it stores around 4.7 GB on single layer or 8.5 GB on dual layer data. Blu-ray discs, they store about 25 GB with single layer or 50 GB with dual layer and even more. So connectors, they use SATA for internal connectivity and USB for external connectivity. And their purpose is for installing software, playing movies and music, creating backup on CD read and read write, DVD read and read write, and Blu-ray disc read and read. I think this is erase. So these are becoming less common as digital distribution increases. So in the previous slide, we studied the USB flash drive. So these are relatively gradually replaced. The optical drives are gradually replaced by the USB flash drives. Our next objective 3.5 is given a scenario, install and configure motherboard, central processing unit, that is CPU, and add-on cards. So motherboard form factor introduction. So these are standardized physical dimensions and layout of a motherboard. It determines the size of the case the motherboard will fit into, and it affects the number of expansion slots and other features. Key form factors of motherboards include ATX, micro ATX, and ITX. Motherboard form factor, first one is the ATX, that is Advanced Technology Extended. So this is standard full size motherboard form factor, and its size is typically 12 into 9 inches. And features include that it offers the most expansion slots, including PCIe, PCI, and more RAM slots and more connector. It is because it has the, you can say, the largest size. Case compatibility, it requires a mid tower or full tower ATX case, such as this one. Pros include that it has maximum expandability and good airflow potential. Cons include that it is the largest form factor and required larger case. Next form factor is the micro ATX. So this is the smaller version of ATX. Size is 9.6 into 9.6 inches. Features include it has fewer expansion slots, usually 2 to 4, fewer RAM slots, typically 4, but retains many ATX features. Case compatibility is that it fits in micro ATX and some ATX cases. Pros include that it has smaller size, often more affordable than ATX, and good balance between the feature and the size. Cons include that it has limited expandability as compared to the larger ATX. Next is the ITX, that is Information Technology Extended, and it is compact form factor designed for small form factor systems. So it has various sizes within the ITX family, including the mini ITX, which is 6.7 into 6.7 inches. Features include it has typically 1 to 2 expansion slots, often PCIe slots, usually 2 RAM slots, and integrated components are common in this version. Case compatibility, it requires ITX or small form factor cases. Pros are that it has a very small size, lower power consumption, and ideal for compact builds. Cons is that it has again limited expandability due to smaller size, can be more expensive, and may have limited feature compared to larger form factors. So motherboard connector types, and the first one is the PCIe, that is Peripheral Component Interconnect. So these are older expansion card interfaces. appearance are longer and wide slots such as these one. Purpose is these were used for older add-on cards like sound cards, network cards, and some older graphic cards. It has slower speeds than PCIe, becoming less common on modern motherboards. Next one is the PCIe, that is Peripheral Component Interconnect Express, and this gives us higher speed serial interface for expansion cards, or you can say this is the higher speed serial interface for expansion cards. In appearance, it has shorter slots in various sizes, that is X1, X4, X8, and X16, often black on or other colors. So the purpose is that it is primarily used for graphic cards, the X16 one, but also for high-speed SSDs, network cards, and capture cards, etc. It gives much faster speed than PCIe with different generation, has different generations such as PCIe 3.0, 4.0, and 5.0, offering increasing bandwidth. Next, motherboard connector types are the power connectors. So these connect the power supply to the motherboard. It has 24-pin ATX power connector, main power connector for the motherboard. We can see that this is the motherboard power connector, 8-pin 4 plus 4 EPS power connector. This provides additional power to the CPU alone, maybe this one, and 4-pin ATX 12-volt connector. This was older or supplementary CPU power. Next motherboard connector types are the headers. So these are pin connectors for various internal components and front panel connections. So the front panel headers include the power button, the reset button, and power or hard disk drive LEDs. USB headers include internal USB 2.0 and USB 3.0 or 3.2 ports for front panel or internal devices. Fan headers for connecting case fans and CPU coolers, PWM and voltage controlled. Audio header for front panel audio jackets. Another motherboard connector type is M.2, which is the small form factor connector for high speed SSDs and other devices. So we are talking about this one. In appearance, it is small horizontal slots with a key that is notch indicating supported types, for example, M key and B key. It supports SATA and NVMe, that is PCIe SSDs, Wi-Fi and Bluetooth modules, and it offers higher bandwidth and compact size. So, introduction to motherboard compatibility. So, ensuring compatibility is crucial for a working system. CPU socket type is the primary compatibility factor, and multi-socket motherboard required specific CPUs. Now coming over to CPU socket type, and the first one is the AMD. So AMD uses various socket types over times. Example include AM4, which is used for many Ryzen CPUs such as this one, AM5, which is the current generation socket for Ryzen 7000 and later, and Tier 4 TRX 4 SWRX8. These are the high-end desktop and workstation sockets for Threadripper CPUs. So check the motherboard specification for supported AMD CPU series and socket types. So CPU socket types introduction. So it is the basically physical interface between the CPU and the motherboard, such as this one. And there are different manufacturers such as AMD and Intel uses different sockets. Sockets are not interchangeable between manufacturers. So you cannot install Intel CPU in AMD socket. Sockets also change over time as new CPU generations are released. So let's first discuss the Intel socket type. So Intel uses various socket types. Example include LGA 1700, which is the current socket for 12, 13, and 14 generation Intel Core processors. LGA 1200 was used for 10th and 11th generation Intel Core processor, and LGA 2066 is used for high-end or desktop socket. Check the motherboard specification for supported Intel CPU series and socket type. So each manufacturer motherboard has the manual that gives the supported manufacturer CPU series and socket types. Next one is the multi-socket motherboard. So these are designed to support multiple CPUs. So multi-socket means you can physically install multiple CPUs in multiple sockets. So they are primarily used in server and high-end workstations, and they require specific CPU designed for multi-socket configuration. For example, Intel Xeon Scalable or AMD YC, and they offer increased processing power and memory capacity. So some comparison between single and multi-socket motherboards. So the use case for single socket is the consumer, desktop, and laptop, while the multi-socket are used for server and high-end workstation. As far as performance is concerned, the single socket has one CPU, so less performance, and the multi-socket has 2+ CPUs. It means it gives us parallel processing and more performance. The single socket cost is lower, it is cheaper, while the multi-socket motherboard are of course at a higher end. As far as power and cooling is concerned, the single socket required moderate power and cooling, while the multi-socket required advanced cooling and more power. So our next topic is the BIOS or UEFI settings. So first software that runs where a computer is powered on is known as BIOS. So this is the first software that runs when you power on your system, even before the operating system. So it initializes the hardware and provides boot options. Modern system uses UEFI, that is Unified Extensible Firmware Interface, which is a more advanced interface as compared to older BIOS. And it is accessed usually via a specific key during startup, for example, del button, F2, F12, etc. So boot options, what are the boot options? So the boot option determines the order in which system tries to boot from different devices. And it allows selecting boot devices like hard drive, SSD, USB drive, or DVD CD-ROMs. It is essential for installing an operating system or booting from recovery media. So boot order priority can be changed in the BIOS or UEFI settings, such as here in this screenshot. Next is the USB permissions. So it allows enabling or disabling USB ports for security or troubleshooting. So you can control whether the system can boot from USB devices. It is useful for preventing unauthorized data access or malware infections. And there are specific settings vary depending on the BIOS or UEFI implementation. Our next topic is the TPM, that is Trusted Platform Module, which is a security related chip inside modern system, and it has different security features. So TPM is a hardware security module on the motherboard, such as this one. And it is used for features like secure boot and your hard drive encryption, for example, BitLocker that is used inside Windows. BIOS/UEFI settings allow enabling, disabling, and configuring the TPM. So TPM is required for Windows 11 and other security conscious applications. What are some fan considerations in CPUs and motherboards? So BIOS UEFI allows monitoring fan speed and system temperatures. Fan speed basically control option that is PWM voltage help regulate cooling and noise. So in fan configuration, you have options such as these which help regulate the cooling as well as noise. And you can set fan curve based on CPU or system temperatures. Proper fan configuration prevents overheating and ensures component longevity. So what is the secure boot? So UEFI security feature that helps prevent malicious software from loading during startup. It verifies the digital signature of bootloader and operating system files. So it requires TPM, that is trusted platform module, to function effectively. So in secure boot, you use the TPM security features and it should be enabled for enhanced system security. What is the boot password? So the password that is required to boot the computer before the operating system loads. So it is not the operating system username and password. It is the BIOS, you can say BIOS passwords. So it provides a basic level of physical security and it can deter unauthorized access to the system. So you have to remember this password, as forgetting it can make the system inaccessible. Next is the BIOS password, that is also known as supervisor password. So this password is required to access the BIOS or UEFI setting menu itself, and it prevents unauthorized changes to the system configurations. It enhances security by controlling who can modify boot order, security setting, etc. And it is also crucial to remember this password. Temperature monitoring. So BIOS UEFI displays real-time temperatures of CPU and motherboards, etc. It is useful for diagnosing cooling issues or potential hardware problems. So you can set temperature thresholds and warnings in some BIOS and UEFI versions. So it is important to regularly check temperature so it can help ensure system stability and longevity. So what is the conclusion? So the conclusion is that BIOS is essential for initial system setup and configuration, and boot options basically control the startup sequence of your system. Security features like USB permission, TPM, secure boot, and passwords protect the system's integrity and confidentiality. The fan control and temperature monitoring ensure system health. Our next topic is the virtualization support. Virtualization basically allows a single physical machine, that is host, to run multiple virtual machines known as guests. And it requires CPU features like Intel VTX or AMD-V. It is basically enabled in the BIOS settings and it is used for running different operating systems, testing environments, and server consolidation. Next is the encryption that can be performed using TPM, that is Trusted Platform Module. So hardware security module on the motherboard, TPM, the hardware security module or chip available on the motherboard. It is used for storing encryption keys, verifying hardware integrity, and enabling features like secure boot and BitLocker that is used for drive encryption. TPM 2.0 is the current standard. Next is the encryption, and the subtopic is the hardware security module, that is HSM. So what is HSM? HSM is a dedicated hardware device for managing and storing encryption keys, and it provides a higher level of security than software-based key storage. It is used in enterprise environment for sensitive data storage and encryption. Next topic is the CPU architecture x86/X4. So it is the dominant architecture for desktop and laptop computers. x86 is the 32-bit architecture, while x64, also called N64 or Intel 64, is the 64-bit extension of x86. Most modern CPUs and operating systems are x64, that is 64-bit. x64 allows for more RAM and better performance than x86. So I think the x86 or 32-bit operating system can support a maximum of 4 GB RAM, if I am correct, while the x86, it has a higher RAM capacity and capability. Next CPU architecture is the ARM. So it uses the reduced instruction set computer, that is RISC architecture, and it is common in mobile devices, embedded systems, and some laptops. It is known for its power efficiency, that's why it is used in portable devices, and it is increasingly used in servers and desktop computers as well. So what are the CPU core configurations? So modern CPUs have multiple cores, for example, dual core, quad core, hexa-core, or octa-core. More cores allow for parallel processing, improving the performance, especially in multitasking. Hyper-threading, that is from Intel, or simultaneous multi-threading from AMD allows each core to handle multiple threads, further improving the performance. So now coming over to CPU architecture comparison. So the addressable RAM, as I said, the x86 or 32-bit has the addressable RAM capacity of up to 4 GB only, while the x86, x64 or 64-bit has larger RAM capacity than 4 GB, while the ARM RAM capacity varies by design. Whereas the power efficiency is concerned, the x86 requires moderate power, x64 also requires moderate power, or you can say the power efficiency is moderate, while the ARM or RISC architecture has very high power efficiency, then that's why it is used in mobile devices. Use case is that x86 is used in legacy PCs. It is no longer used in modern PCs. x64 is the modern PC standard, while the ARM is used in phone, tablet, Internet of Things, etc. As far as instruction set is concerned, the x86 uses the complex CISC instruction set, while the x64 instruction set is also complex, while the ARM uses simplified RISC instruction set. Our next topic is the expansion cards. So expansion cards are installed into motherboard slots, usually the PCIe slots. They add or enhance the system functionality. Example of expansion cards include the audio, video, networking, and capture cards. The first one is the sound card, which enhances audio quality and output channels, and it is useful for music production or gaming, and it replaces the onboard basic sound or audio feature. Next is the video card, which handles the graphic processing, and it is crucial for gaming, 3D rendering, and video editing, and it is installed in the PCIe X16 slots. Next expansion card is the capture card, which is used for recording video from external sources such as console or camera, and it is used in streaming setups and can be internal when used on the PCIe slots or external through USB on Thunderbolt interfaces. Next is the network interface card, which adds wired or wireless network access. It is useful for onboard. It is useful if the onboard network interface card fails or is missing. So this one, the expansion network interface expansion card can be used if the onboard NIC fails, and it may support faster speed up to 10 gigabit per second. Our next topic is cooling. So cooling prevents overheating and thermal throttling, and it increases system stability and component lifespan. So there are different solutions for different needs of cooling. First one are the cooling fans. So they move air across components, and they are available in case fans, CPU fans, or GPU fans, and they are controlled via BIOS or software. Next one are the heat sinks. So these are metal blocks with fins that absorb and disperse heat, and they are often combined with a fan that is air cooling, and they are passive or they provide passive or active cooling. These are, I think, used with the CPUs installed basically on the motherboard. Next one are the thermal paste or pads. So these improve heat transfer between CPU and heat sink, and they fill microscopic gaps, and they must be applied properly for efficiency. Next one is the liquid cooling. So they uses liquid coolant to transfer heat away from the component. So this cooling method is quieter and more efficient than air cooling, but it requires more space and maintenance. So the key takeaways are that the sound cards, like sound card, or you can say the expansion card or sound expansion card is used to improve the audio quality, and it is used for gaming and music production. Video expansion card handle graphic rendering and used for gaming, 3D design, and video editing. Capture card basically records external video input, and it is used in streaming setups. And network interface cards adds or upgrades network access, and it is used in server builds and if you require faster networking speeds. Similarly, fans move air to cool the components of the CPU and motherboards, and it's almost used in all systems. Heat sinks are used as a passive heat dissipation, and they are used for cooling of CPU, GPU, and chipset cooling. Thermal paste maximizes the cooler to CPU contact, and they required with any heat sink technology. While liquid cooling is silent and provides higher performance cooling as compared to air cooling, and it is used where for overclocked or high heat systems. So now coming over to the power supply installations. So the power supply unit provides power to all the components in the system. So selecting the correct CPU, correct PSU, that is power supply unit, is crucial for stability and reliability of the system. So consider factors like wattage, connectors, and efficiency when shopping or considering the PSU. So input voltages may be 110 to 120 voltage or 220 to 240 voltage. So power supplies are designed for specific input voltage ranges. 120 to 120 voltage are standard in North America and some other regions, while 220 to 240 voltage are standard in Europe, Asia, and many other parts of the world. So selector switch, so some power supply units have a selector switch as a voltage selector switch, which ensures that it matches your local voltage. Automatic switching may also be used. So many modern power supply units automatically detect the input voltage and switch to it accordingly. Incorrect voltage, using the incorrect voltage may damage the power supply unit as well as the system. Output voltages may be 3.3, 5, and 12 volts. So modern computer components require different DC voltages. First one is the 3.3 voltage. So it is typically used for RAM and some motherboard logic. 5 volt is used for some USB devices, certain motherboard components, and older peripherals, while 12 volt is primarily used for CPU, graphic cards, and motors in drives and fans. 20 plus 4 pin motherboard connector. This one is the main power connector for the motherboard. So in older motherboard used 20 pin connector. Modern motherboard uses a 24-pin connector, often supplied as a 20-pin connector with an additional 4-pin section, such as this one. So it ensures sufficient power delivery to the motherboard. The 4-pin section can be detached for compatibility with older 20-pin boards. Redundant power supply. So the redundant power supply basically uses two or more power supply units working in parallel, such as this one. We have two power supply and they are modular. If one power supply fails, the other can take over, preventing system downtime. And they are primarily used in servers and mission critical systems. So they require a specialized chassis and motherboard support. Energy efficiency. So energy efficiency measures how efficient PSU, that is power supply unit, converts AC power from the wall into DC power for the computer. Higher efficiency means less wasted energy as heat and lower electricity bills, often indicated by an 80 plus certification, including bronze, silver, gold, platinum, and titanium certifications. Higher tier certification indicate greater efficiency. So the titanium certification has a greater efficiency than bronze and silver. Conclusion. So ensure correct input voltage for your region. Verify sufficient output wattage for all the components of your system and motherboard. Choose a power supply unit with the necessary connectors. Consider redundancy for critical system, meaning using multiple power supply units. And modularity adds in cable management and air flow. Higher efficiency saves money and reduces heat dissipation. So our objective 3.7 is, given a scenario, deploy and configure multifunction devices, printers, and settings. Let's get started. To deploy and configure multifunction devices slash printers, So proper deployment ensures optimal performance and user satisfaction. Consider physical setup, driver installation, and network connectivity to your printer. Configuration involves adjusting settings for specific needs. So the first configuration step is unboxing and setup location. So remove all shipping material, install the ink and toner cartridges, and load the paper trays. So choose the location that has proper ventilation, access to the power and network connectivity, and clearance for paper handling. It has sufficient place so that you can remove the jammed paper and clear it. Next is the driver selection. So we have multiple choices. One is the PCL, that is printer control language. It is HP proprietary and it provides faster printing but is less precise. Next one is the PostScript, which is the Adobe standard. It gives better graphics and is commonly used in publishing. So next is the firmware management. So check the manufacturer website for the latest firmware and update the firmware via the USB network or device menu as per your specific device. Benefit of firmware upgradation and updation is it includes security patches, new features, and it fixes different bugs. So wired connectivity of the printers include the USB connectivity, which is commonly used for a single computer and it has a simple setup. So you connect the USB cable to the printer and the other sent to your laptop and desktop. So that's it. It is a simple setup. The next wired connectivity is the Ethernet, which is the when the printer is required to be shared with multiple user and system over the network. This one is more reliable and it requires IP configuration for network connectivity. Wireless configuration include no physical cable requirements because the printer is connected wirelessly with Wi-Fi. It can use Wi-Fi direct or join the existing Wi-Fi network. It ensures you need to ensure strong signal connectivity and use proper security such as the WPA2 or WPA3. And instead of DHCP, you need to assign static IP to the printer if needed. So usually our mobile devices such as laptop and our smartphones, they obtain IP dynamically through DHCP from the Wi-Fi router, but the printer most of the time needs static IP. Shared printing solution include direct share. So this is the basic window sharing solution and it deploys single computer as a host, while the next advanced sharing is through the print server, which is a dedicated server for the print sharing and print management. So it has a centralized driver deployment and you can monitor the printer queue and printer spooling, etc., as well as the print job on the print server. So some advanced configuration include the duplex, which is the automatic double-sided printing, orientation, which is the portrait or landscape preset printing, tray selection, which is the letter versus legal versus photo paper. You can also select qualities. Draft includes 600 dpi. The standard is 1200 dpi, while the high resolution is 2400 dpi. Some print related security features, it may include user authentication to either the PIN codes or you can integrate the printer with the AD. for security authentication of the users. So it may include the badge readers such as RFID and NFC that can be used as a tap to print. Audit logs is a track. Audit logs are used to track usage by the user or the departments. And secure print features are the jobs only print after authentication. It means that it will print only after the user has authentication. Now coming over to some scanning services. So scanning services can be used for email content scanning and then sending the scanned content directly to inbox. SMB shares that is saving them to the network folder. Cloud services such as OneDrive or Google Drive. So what is the difference between the ADF versus the flatbed scanning? So ADF is the used for multi-page document scanning, while the flatbed such as this one is used for books and fragile items. Our last objective 3.8 is given a scenario, perform appropriate printer maintenance. So introduction to printer maintenance. So regular maintenance of the printer prolongs its lifespan. It prevents common issues like paper jams and print quality problems. So different printer technology requires specific maintenance tasks. So the first one is the laser printer maintenance. So it includes the toner replacement. So before replacement, shake the new cartridge and remove the sealing tab. Maintenance kit is replace the roller and fusser and reset the page counter. Calibration include the color alignment and density adjustment, and cleaning is the static charge roller or using the paper cloth. Next is the inkjet printer maintenance, which includes the cartridge replacement. So don't touch the copper contacts on the cartridge. Run alignment after. And the print head cleaning include may be done through software utility or manual wipe using the alcohol pad. Jam clearing is can be done by first powering off the printer and then follow the paper path and clear the jam. And roller cleaning can be done through damp cloth and without using any alcohol. And next one is the thermal printer maintenance. So the paper replacement can be done using correct thermal paper and avoid fingerprint marks. Heating element cleaning, which is isopropyl alcohol to 90%, and before cleaning, power off the printer completely. And debris removal can be done through compressed air, and no sharp tool should be used for debris cleaning. Impact printer maintenance. So ribbon replacement, check the tension and align properly. Print head care, clean with alcohol swab and replace when spent. Paper handling, adjust tractor feed and store multiple paper flat. So summary of the printer maintenance is that laser type printer use the consumable in the form of toners, and key maintenance tasks includes to replace the toner, clean the interior and use the maintenance kit. While the inkjet uses the ink cartridges, and the maintenance tasks include cleaning the print heads, calibration, aligning, and clearing the jam paper. Thermal consumables or thermal printer use the thermal papers, and maintenance include clean heating element, and feed roller, while the impact printers uses the ribbon and paper, and the maintenance include replacing the ribbons, print head, and handling the multipart. So that's it for this domain. I hope it has been informative. So please like, subscribe, and stay tuned for the next domain. Welcome to our domain for virtualization and cloud computing. And objective 4.1 is explain virtualization concepts. So let's get started. So our first topic is introduction to virtual machines. So a virtual machine is a software-based computer. What does this mean? This means that we have one main hardware and then we can create multiple software-based computer, also known as VM, on this one main hardware. So each of these VM has its own operating system, its own resources such as CPU, RAM, storage, and network interfaces, and they act like a separate computer. So we can say that they are computers within a computer. So the VMs are isolated from the host operating system as well as from the other VMs. So the virtual machine offers us a flexibility and efficiency in our resource utilization. So traditionally, only one operating system was installed on the computer or on the hardware, but due to virtualization, now we can install multiple operating system and create multiple VMs, and in this way, the resources, underlying hardware resources, are utilized in more efficient way. So now some use cases or purposes of the virtual machine, and the first one is the sandbox. So sandbox is an isolated environment for testing software or configuration. So as we can see, let's suppose you have a software that you want to test, but you are worried that the software may affect the services. So you can create a VM and test that software in an isolated environment. So the sandbox allows experimentation without risking to the main host system. So as we saw that we have the main hardware, and upon the hardware we can create multiple sandbox or multiple VMs, and we can experiment with these VMs without affecting the underlying hardware or the underlying host. So when we are done with the testing, we can easily revert or discard the sandbox and freshly create a new VM from the scratch. So this sandbox are the VMs that we can use as a sandbox. They are ideal for exploring potentially unstable or unknown application. So let's suppose we have an application, but we are worried that the application may contain malware. So we can test this application inside a separate VM known as the sandbox, and thus we can study the behavior of the application without affecting our main or our underlying host or the operating system. Another test case or the purpose of the virtual machine is the test development environment. So we can create consistent and reproducible test environments. So since the VMs are easily created within minutes, so we can create multiple consistent environment from a single VMs. And we can simulate different operating systems and hardware configuration. So we can, for each VM, we can create, let's suppose, different OS as well as different hardware configuration. For some VM, we can give, let's suppose, 2 GB RAM. For another, we can provide 4 GB RAM, and we can study the behavior of the our testing environment or our testing application. So this facilitates efficient software development and quality assurance. So we can test our application and their quality under different VMs environments. And this also streamlines the testing process across multiple platforms. So we can test the application on multiple platforms. Let's suppose we have Linux over here. We have, let's suppose, Windows 10 over here, and we can have Mac over here. So we can test our application across multiple operating system and multiple hardware configurations. Application virtualization, that is legacy software or operating system. So if we need or we have some outdated application that run on older operating system, what we can do, we can create a VM, and we can, let's suppose we need an XP operating system that is required by an application. So we can create a VM, install an XP operating system on that, and install that application on that operating system without affecting or any changes to our underlying main host. So in this way, we can avoid compatibility issues. So let's suppose our next application requires, let's suppose, Windows 10. But that old application is not compatible with Windows 10. So we can create a separate operating system for that legacy application, that is Windows XP, and prevent the compatibility issue. And in this way, we can preserve and keep using our critical legacy systems without discarding them. So now coming over to some virtualization requirements, that what things or what requirements such as software, hardware, or networking needs are to be done in order for the virtualization to take place. And the first one is the security. So security means that the VMs must be isolated from each other. Their operating system and their configuration file should be separated from each other. Their processes must not interact with each other. So in this way, if one VM is infected by a malware, other VMs on the host are protected from that same malware. So the main underlying operating system of the virtualization is known as the hypervisor. So hypervisor is basically, you can say, this is, let's suppose, our hardware or our server, and hypervisor is the virtualization layer that need to be installed on that bare metal hardware for virtualization to take place. So this hypervisor must be secure and from a reputed vendor. Our second requirement is the network. So each VM needs connectivity and IP addresses. They must be provided IP addresses as per the requirement, either through DHCP or manually. So there are virtual switches also required for traffic control. So there are virtual switches, and then they need to be configured for traffic control and traffic flow. And you can control the VM traffic such that they can only communicate with the internal network, or they can also communicate the external network as per the requirements. Another requirement is the storage. So each VM uses a virtual disk. So large storage is needed for virtual VM. So let's suppose if you are deploying dozens and hundred of VMs, you will need a large storage because each VM required a separate virtual disk, and they will accumulate, and you will have to configure large storage on your underlying hardware. So what does this backup app snapshot mean? So this means that each VMs have snapshots. These are images that are lightweight and needs very low storage, and they are essential for the backup solution. So if your VM, let's suppose, fails or is accidentally deleted, you can recreate the VM from these snapshots, or you can also create new VMs from these snapshots in a few clicks. So now coming over to our next topic, that is desktop virtualization. So desktop virtualization is basically accessing desktop environments remotely. What does this mean? This means that we have, let's suppose, we have Windows 10 desktop. So instead of installing these desktops on each individual clients, these desktops are remotely installed on servers and they are accessed remotely by the client. So these desktops are not directly installed over here, they are accessed over the network. So you have a centralized control and management of these desktops because you can control them from these server instead of installing or configuring each individual client. So as I said, you run these desktop machines or these operating systems on servers instead of local PC or local clients. So a related concept to the desktop virtualization is the virtual desktop infrastructure or VDI. So these VDI delivers full desktop environments over the network, and each user gets a personal or a virtual desktop. What does this mean? This means that let's suppose you have a laptop over here. So you get a VM remotely from the server over the network. So this is RTL for remote work and thin client. So thin client means traditionally we have laptops that are thick client, and these laptops has their own operating system. Thin client means that these client does not have their own operating system. The operating system is taken in the form of VM, or you can say virtual desktop over the network. Another related concept is the containers. So containers are lightweight, standalone, executable package of software, and they contain everything that is needed to run an application, that is code, libraries, and dependencies, etc. So they share the host operating system kernel, making them more resource efficient than the VMs. So here we can see that we have a server. On the top of the server we have an operating system. This operating system can be Linux, can be Windows. On top of that we have the container engine, or you can say Docker engine. And on top of that we have these environments that we talked about, the code, libraries, dependencies, etc., and the container. So in the VMs, each VM has its own operating system, but the container does not have its own operating system. They share the underlying operating system. That's why we can say that the container are lightweight and much more resource efficient as compared to the VM, because the operating system is heavy and required resources, and since VMs has own operating system, they required high resources as compared to the container who share resources of a single operating system. So container provide portability and consistency across different environments. What does this mean? That you can shift this container as a portable application and you can move it anywhere to another Docker engine and they will run instantly. So now coming over to a comparison between the containers and the virtual machines. So in the case of VMs, we virtualize the hardware and run entire operating system. So here we can see each VM has its own operating system. while in case of a container, we virtualize the operating system and package application and dependency. So what does this mean? This means that this operating system is shared between containers. So in a way, we can say that we virtualize the operating system, while in the virtual machines, these hardware resources, they are shared with each VM, and each VM then install its own operating system upon these shared hardware resources. So VM has large footprints, slower boot times, and higher resource consumption. While on the other hand, container has smaller footprint, faster boot time, and lower resources consumption, as we already studied. So VMs have stronger isolation because each VM has its own operating system and is not dependent upon the underlying operating system. Container has shared operating system and shared kernel, so that's why their isolation is potentially less as compared to VMs. So now coming over to hypervisors. So hypervisor is basically software that creates and manages the virtual machines. So this hypervisor acts as an intermediary between the physical hardware and the VM. So this is our hypervisor. This is the main hardware and these are the VM. So this acts as an intermediary between our VMs and our hardware. We can say that hypervisor basically controls the hardware and provides this hardware to the VMs and control it. So it allocates, as I said, CPU, RAM, storage, and networks to the VMs. And we have two main types of hypervisor, that is type 1 and type 2. And now we will study both of these one by one. So first of all, the type 1 hypervisor. As we can see, type 1 hypervisor is directly installed on the bare metal hardware, and upon that hypervisor we create different VMs, and each VM has its own operating system. So it installed directly onto the physical hardware, no host operating system. So we have no operating system over this hardware, no Windows, no Linux. Hypervisor is directly installed on this hardware. It is highly efficient and performant. So this one is more efficient as compared to type 2 hypervisor. So example of type 1 hypervisor are the VMware ESXi, Microsoft Hyper-V Server, and Critics hypervisor. So these are the commercially available hypervisor, and they are used by the organization and companies inside their data center. So they are commonly used in server environments and data center. The second type of hypervisor is the type 2 hypervisor. So this one runs inside a host operating system. So we have hardware. On top of the hardware, we have an operating system. Let's suppose we have Windows. And on top of that operating system, we install the hypervisor software, and on top of that, then we create VM. So it is easier to set up for personal use. What does this mean? That it means this is the type of hypervisor that we use on our personal PCs and laptops. So this hypervisor, type 2 hypervisor performance can be impacted by the host operating system. Example of type 2 hypervisor include the VirtualBox and VMware Workstation. So now coming over to the summary. So VM are basically used for full OS isolation. Each VM has its own VM, and examples of hypervisor or VM's isolation are the VMware and Hyper-V. Basically, VMware ESXi is the type of hypervisor from VMware, and this is the Microsoft hypervisor, that is Hyper-V. So VDI is used for remote desktops, And tools used for VDI, that is virtual desktop infrastructure, are Critics and Azure Virtual Desktop from Microsoft. Containers are used for app portability, for moving or exporting apps from one environment to another, and its tools are Docker and Kubernetes. Type 1 hypervisor are used inside data center and on enterprise servers. And examples include ESXi from VMware and Hyper-V from Microsoft. And type 2 hypervisor are used by individual users for local testing, and its examples include the VirtualBox and Parallels. So our objective 4.2 is summarize the cloud computing concept. First of all, an introduction to the cloud computing. So cloud computing is delivering the computing services including servers, storage, database, networking, software, engineering, and intelligence over the internet, that is over the cloud. So traditionally, we use all these services on our local PCs inside our local network. But in cloud computing, all these services are delivered over the network or over the internet. So these are offered on demand access to a shared pool of configurable computing resources. Shared pool means that these resources are offered by a company to multiple customers, so they are shared among multiple customers. Cloud provides scalability. They can be scaled up or scaled down as per the requirements, flexibility. They are easy to manage and they have the flexibility for scalability and cost efficiency. So they are cost efficient. Instead of deploying your own hardware, software, you can easily get your required resources from the cloud as per your requirement and as per your demand. So the cloud services often relies heavily on virtualization technology. So the underlying infrastructure of the cloud computing is the virtualization and the hypervisor technology that we just studied. So now coming over to different cloud deployment models. So we can deploy cloud services in different ways. So the services or cloud deployment model are chosen based on what type of control, cost, and flexibility is required. And there are four main deployment model. And the first one is the private cloud. So it is used by only one organization. So the private cloud is dedicated for only one organization. Let's suppose organization A, and it gives us more control and more security because no other user can access the resources of this cloud. And this cloud can be on-site or hosted by providers. So you can host the cloud inside your own organization, or this can also be provided by another provider, but it will be dedicated for that specific user. It will not be shared with another organization. Next one is the public cloud. So as the name indicates, this is shared among many users and many companies, and it is managed by cloud providers such as AWS, Azure, and Google. And the public cloud is basically scalable and very cost efficient. It is cost efficient because it is shared among multiple organizations. Then we have the hybrid cloud model, which is the mix of private and public cloud. So some organization may require the acquire the services of a public cloud, and they may also have their own private cloud. So this is because these organizations may have very sensitive data that they don't want to deploy on the public cloud. So that sensitive data stays on the private cloud, and the public cloud is used for other general purposes. And then we have the community cloud. So the community cloud is shared by organizations with common needs. For example, government, healthcare, and educational organization. Multiple organizations can create their own cloud and they can share resources among themselves as well as use the application, common application among themselves. So this one is known as the community cloud. So this is more secure than the public cloud, you can say, because it is only shared by a few organizations, but you can say it is less secure than the private cloud. Now coming over to cloud service models, and our first service model, cloud service model is IaaS, or infrastructure as a service. So this type of cloud model basically runs the infrastructures that is server, storage, and networking. And the customer basically install the operating system and manages as well as the software on top of that operating system. Example of the infrastructure as a service include the Amazon EC2, that is Elastic Compute. I think Elastic, I don't remember the exact abbreviation, but it is something like Elastic Compute, and Microsoft Azure VM. Our next cloud service model is the PaaS, that is platform as a service. So this type of cloud service model provides pre-built environment for application development. So the customer does not need to manage server or underlying operating system. Example of the platform as a service include Google App Engine and Azure App Service. And our third cloud service model is SaaS, or software as a service. So these are ready to use applications that are served or available over the internet by the cloud provider, and the user do not need any installation or any maintenance of the underlying infrastructure, operating system, or these applications. You simply have to pay for the usage and simply use the application. Example of software as a service include Gmail, Office 365, and Salesforce. So now coming over to some cloud characteristics. So cloud basically provides us with shared resources, and that's why it is more cost effective due to economies of scale. So cloud requires robust security and isolation mechanism. Since multiple organizations and customers are using the same resources, strong security and isolation is needed so that one customer accidentally or intentionally does not access other customers' data. So it is common in public cloud environment where multiple customers share the pool of resources. So multiple user organizations utilize the same underlying physical infrastructure. That's why it has the economy of scale. So some cloud may provide dedicated resources, such as in case of private cloud. So resources are reserved for a single use or for a single organization, and this offers greater control and potential better performance. But it is also more expensive as compared to public cloud, and it is common in private cloud environment or for specific public cloud offerings. Another cloud characteristic is the metered utilization. What does this mean? This means that cloud resources are typically billed based on actual usage. So you are charged for the time being or for the resources that you actually use. It is not such that if you have subscribed for a month and if you do not use the cloud resources, you will be charged fully. So you are only charged for the resources that you use, and this model is generally known as pay as you go. So this model basically reduces the upfront cost. So you do not need to install your own hardware, your own infrastructure, operating system, cooling system, etc. So you have no upfront cost. You just pay as you go. So it allows for granular cost management. So you can manage the cost of your consumption. So it includes various metrics like compute time, or how time the compute is used, how much storage is consumed, and how much data is transferred over the network. So ingress means that data transfer inside the cloud, it is often free or has lower cost. You can also say that data uploaded to the cloud. And the egress means data transfer out of the cloud environment. Typically, this includes charges, or you can say this may be taken as the data downloaded from the cloud. Another cloud characteristic is the elasticity. Elasticity means that cloud resources auto scale down or scale up. So when the traffic or when the requirement is high, users are in great numbers, then the resources scale up as per the requirement, and when there is low activity, users are in low number, then the cloud resources scale down. So it handles peak traffic and low demand. So when the traffic is peak, the resources are scaled up, and when demand is low, resources are scaled down, and this characteristic is basically the elasticity. So it saves cost and boosts performances. Another characteristic is the availability. So cloud is always available as long as you have the internet connectivity, and it has usually 99.9% uptime. It is because the cloud data is stored across multiple locations, such as this diagram. The cloud may have multiple availability zones, such as this one, and inside each zone we have multiple data centers. So if due to some natural or man-made disaster one zone is down or unavailable, the user can access resources from second zone. If that zone is also unavailable, the user can still have accessibility of resources from the third zone. So the redundancy helps avoid downtime. As I explained, we have multiple redundant data centers and location. So this avoids downtime of the resources. File synchronization means that cloud helps sync files across devices and location. So it provides us real-time access to the latest version of the application, for example, Google Drive and OneDrive. And cloud provides with the multi-tenancy. So what does this mean? That multiple customers share the same infrastructure. As in this case, we have multiple customers and they are sharing the same underlying physical infrastructure, but data is separated securely. Even they are sharing same underlying infrastructure, the data is still separated. So this way it provides, as we already studied, efficient resource utilization. So that's it for this domain. I hope it has been informative. If there is any confusion or any question, please drop in the comments, and I will see you in the next and last domain. Welcome to the domain 5, hardware and network troubleshooting. So our first objective 5.1 is, given a scenario, troubleshoot motherboards, RAMs, CPUs and power. Let's get started. Introduction to hardware troubleshooting. So in these lessons, we will study some common hardware failure systems. We will try to diagnose and resolve different system issues. And we will study some tools and methods for effective hardware and network troubleshooting. First of all, some power on problems and beep codes. So when you first power on the system, it tests itself using the post, that is power on self test beeps. So the beeps are basically specific patterns of sounds that indicates hardware failures and its components such as RAM, GPU and CPU. And to understand these patterns, you need to refer to the vendor motherboard manual for their meanings. So if you encounter the blank screen, the system is receiving power, but the screen is blank. It means that you may have the GPU, the display, or the monitor, and the connection issue. The connection means connection between the display and the motherboard. And if there is no power, input power to the system, you may have the faulty power supply, or there may be no input power from the wall outlet, or your power button may be faulty. System instability and performance issues. So different operating system and different vendors have different crash screens. For example, Windows have BSOD, that is blue screen of death, and Linux and macOS has kernel panic. So these screens may indicate the driver issues or hardware failure. So these screens also have a message with them, and this message may indicate the type of error that the system is now experiencing. So if your system is having sluggish performance, such as it is booting very slowly, the application is loading slowly, or the system have general slow performance, these may be due to CPU throttling, insufficient RAM in the system, or the hardware failure, and uh, read-write issues with the storage. And if your system is randomly shutting itself down without any warning or without any message, the issue may be due to overheating or with the power supply. Another instability or performance issue may be with the application crashes. So specific programs stop responding or close unexpectedly during system operations. And these problems may be due to RAM issues, corrupted drives, or software conflicts within the operating system. So now coming over to some physical and auditory clues. So auditory means related to audio or sound. First of all, overheating. Overheating means that some system components such as CPU or RAM may have higher temperature, which may lead to throttling, random shutdown of the system, or permanent damage to the components. So if you encounter these issues, you need to check the CPU cooler, the case fans, and the air flow of the system. If you encounter burning smell, it means that some component is overheating or maybe possibly burning. And if you encounter such issues, you need to immediately shut down the system to prevent permanent damage to the component or the system. If you encounter some unusual noises such as whining, grinding, or clicking sounds, these may point to fan failures, hard drive failures, or the power supply failure. Capacitor swelling means bulging or leaking capacitors on the motherboard itself, and this indicates some component failures and may lead to system instability. System configuration and date time issues. So date and time may revert to an old setting when you power off the system, and this may be due to the dead CMOS battery on the motherboard. So this battery basically keeps the system date and time correct, and if the battery is dead, so your date and time may revert to some old date, and this affects system functionality and secure connections. Secure connection means such as your HTTPS connection. If your date and time is incorrect, you may have you may not your system may not be able to make this secure connection with the server. Now, some general troubleshooting strategies. First of all, you need to isolate the problem, and for isolating the problem, you need to start with the simplest and most obvious checks first. Then you need to check the different connection and cable. You need to make sure that the cable and connectors are properly connected and seated. And you need to check one component and one issue at a time. And if you don't understand the issue, you need to consult the documentation such as the motherboard manual, online forums, or the manufacturer support. Objective 5.2, given a scenario, troubleshoot drive and RAID issue, that is redundant array of independent disks. We have already studied what RAID and different types of RAIDs are. Physical and audible indicator of drive failure. By drive here we mean HDD, that is hard disk drive, such as this mechanical HDD. So the LED of the drive may indicate the issue with the drive. The LED may be solid, on and solid. It may be turning on and off, that is blinking, or it may be completely off. So each of these status indicate the activity, health, or failure of the drive according to the documentation. And if you encounter grinding noises, this may indicate the mechanical failure in the traditional HDDs, such as this one, where we have multiple mechanical parts. And the noise may indicate an imminent drive failure. It means that the drive failure is imminent and you need to shut down the system and back up the data on that drive. So clicking sound, that is click of death in hard disk drive. These clicking sound means that the heads is attempting to read the data but failing, and it indicates mechanical issues and has a very high risk of data loss. So beeping from the RAID controller or drive enclosure, you may hear some audible alarms such as beeping from the RAID controller or drive enclosure, which signals that a critical event such as the drive failure in the RAID or in the array. Boot and data access problems. So bootable device not found. When a system cannot find an operating system to load, you may encounter an error message like that. And this could be due to faulty drive, incorrect boot order, or corrupted operating system. Audible alarms may indicate some missing files, unreadable operating system files are showing some error, and they indicate drive degradation, bad sectors on the drive, or the logical corruption of the drive. You also may have some missing drive of the operating system. A drive previously visible but is no longer detected by the operating system. This could be due to power, data cable issue, or the failure of the drive itself. Array missing means that the entire RAID volume is not detected by the system, which may indicate an issue with the controller, or there may be multiple drive failures in the array. Performance degradation and health warnings. So if you encounter extended read and write times, application or file transfer may take unusually long times, which indicates slow drive read-write performance due to bad sectors or high fragmentation. Low performance or input-output operation per second, so poor responsiveness in disk-intensive tasks, often seen with the failing drives or overloaded storage system. Self-monitoring and reporting technology failure that is smart. So BIOS or operating system reports a smart error. Smart is self-monitoring and reported technology. It is predictive failure warning from the drive itself, and you need to back up the data immediately and replace the drive. And if you have RAID failures, RAID utility or system reports a degraded performance or failed array state, which means that one or more drives in the array have failed. Now, some general troubleshooting approach for the storage. Again, check the physical connection, and the physical connection may include the power connection and the data cable connection. Verify the power supply, ensure adequate power is delivered to the drives. Check the BIOS and UEFI drive. Check that the drive detection, boot order, and RAID settings are correct. Use diagnostic tools available such as manufacturer-specific drive utilities, smart monitoring software, and RAID controller utilities. Isolate the problem, so test each drive individually if possible, and always prioritize the data safety, especially when you are seeing the warning signs. You need to back up the data immediately. Objective 5.3, given a scenario, troubleshoot video, projector, and display issues. So first checks includes the cable inputs and bulbs. Bulb means the LEDs. So if you have incorrect input source, so monitor or project may be set to wrong input. For example, HDMI 1 instead of DP port. So always check the input source first. This is the always first thing to check, that is the correct input source. Then the physical cabling, lose damage on incorrect video cable, for example HDMI, display port, VGA and DVI port. You need to check the cabling, that cabling means that the cablings are not loose, they are not damaged, and they are the correct cable for the correct port. So always verify connection at both ends. And what are some issues with the projector? Burn out bulb, that is projector specific issue, which means that no image or very dim image on projector, and projector will often have an indicator light, such as let's suppose this one. Image quality and clarity problems. Fuzzy image means lack of sharpness or blurry picture. This could be due to resolution mismatch, low quality cable, or signal interference. Flickering, flashing screen, so image rapidly appears and disappears or flashes, often indicates a faulty cable, driver issue, or refresh rate mismatch. Or we may have incorrect color display, so color appear wrong, that is green tint or washed out. So if you have this kind of problems, check the cable connections, driver setting, or monitor color calibration. Dim image, so the display appears too dark. Check brightness, contrast setting, power saving modes, or backlighting issues. Distorted image, stretched, squashed, or geometrically incorrect picture, usually a resolution mismatch or aspect ratio setting. Pixel issues and screen damage, display burn-in, that is image retention. Ghost image of previous content remains on the screen, and this one is more common in older CRT or plasma screens, can also occur on OLED. That pixel, individual pixels that are permanently off, that is black, or stuck on, that is bright. Manufacturing may be due to manufacturing defect or physical damage to the display. Sizing issues may be image may be too small or too large or extends beyond the screen limit. Adjust the resolution, scaling, or display setting in the operating system to resolve such the sizing. Audio and projector troubleshootings. Audio issues that may be no sound or poor sound quality from display or projector. Check the HDMI audio settings, speaker connections, or driver issues. Intermittent projector shutdown. So the projector shut down unexpectedly. It is often due to overheating, clogged filter, or fan failure, or due to bulb issues. So now some common and general troubleshooting strategy for the display. Check the physical connection. Always start with the cables and power. Verify the input source. Ensure the correct input is selected. Test with another device. Connect the display to a different computer or source. Test with another display. Connect the computer to a different monitor or projector. Update and reinstall the drive. Graphics card drives are critical. You need to reinstall or update the drive if you encounter the issue. Adjust the display settings through the resolution, refresh rate, scaling, and color. Objective 5.4, given a scenario, troubleshoot common mobile device issues. Power and charging problems, poor battery health, battery drains quickly, device shut down unexpectedly, capacity significantly reduced over time. So these are some battery related issue of the mobile devices. The battery may also be physically damaged and swollen. So the battery appears physically expanding, such as this one. It can push the screen out on the front, or back cover may open due to this swollen battery, and you need to immediate stop using and replace such battery because it's a safety hazard. Improper charging, so the device may charge slowly or not charge at all. It may be due to issues with the cable or with the power adapter. Software glitches may also prevent proper charging of the device. Physical damage and connectivity woes, so broken screen, cracked, shattered, or unresponsive display. It can affect both the visual as well as the touch input to the display. Physically damaged ports, so charging port, headphone jack, or USB-C port bent or obstructed, which prevents proper connection of accessories as well as charging. Liquid damage may be due to device exposed to water or other liquid, which can cause various malfunctions as well as corrosion. It is often indicated by liquid contact indicator, that is LCIs. Poor or no connectivity, Wi-Fi, cellular data, or Bluetooth may not be working due to poor or no connectivity, which may be due to weak signal, dropped connection, or inability to connect. Performance and input glitches, overheating, the devices become excessively hot to the touch, which can lead to throttling, shutdowns, or component damage. Digitizer issues, touch screens are unresponsive, inaccurate, or register ghost touches, which can be related to screen damage or software issues. Cursor drift or touch calibration, touch input registers in wrong location, which is common with older resistive touchscreen or some stylus enabled devices. Stylus does not work. Stylus input is not recognized or function incorrectly. To resolve the issue, check the stylus battery connectivity or compatibility. Degraded performance, device is slow, applications crashes or multitasking is poor, which may be due to insufficient RAM, full storage or some background running processes. Software and security concerns, malware, so unwanted ads, suspicious pop-ups or unusual data usage, device behaves erratically and slows down, and it can also compromise the personal data. Unable to install new application, errors when downloading or installing apps may be due to insufficient storage, incompatible OS version, or security settings. Some general troubleshooting strategy for mobile devices: restart the mobile device, and it often resolves minor glitches. Check the physical condition, inspect for visible damage to the mobile device port or screen. Update the software, update the operating system and other applications. Check settings, check the connectivity, battery usage, and storage settings. Safe mode or diagnostic mode, boot the device to isolate third-party application issues. Factory reset as a last resort after backing up data, factory reset the device. Consult manufacturer support. If everything else above fails, consult the manufacturer support. Objective 5.5, given a scenario, troubleshoot network issues. First of all, loss of connectivity and access, intermittent wireless connectivity, Wi-Fi connection drops in and out, could be due to signal interference, channel saturation, or faulty adapter or access point. Limited connectivity, device may be connected to the network but has no internal access or local resources, which is often indication of IP addressing issues such as DHCP or incorrectly configured static IP. Intermittent network or internet connectivity, internet connection drops in and out, but local network is stable, which points out to the to issues with the ISP, modem problem, or router instability. Authentication failures, unable to connect to a Wi-Fi network due to incorrect password. This can also be seen with the wired networks using 802.x, also known as NAC, that is network access control. Network performance and quality degradation, low network speeds, data transfers take too long, and browsing is slow, maybe due to congestion, bandwidth saturation, or faulty cabling or hardware. High latency, delay in data transmission, that is low response from websites, may be caused by network congestion, routing issues, or distance. Jitter may be due to variation in delay of received packets, critical for real-time applications like voice over IP and video conferencing. Poor voice over IP quality, choppy audio, dropped calls, or echoes in the call, often caused by high latency, jitter, or insufficient bandwidth. Hardware and environmental influences, port flapping, a network port on a switch or router repeatedly goes up and down, which indicates bad cable, faulty network card, or a port on the switch. External interference may be due to radio frequency interference disrupting wireless signals caused by other wireless devices, microwaves, or electrical noise. Some general network troubleshooting strategy, including verifying physical connections, including cables, light, checking the lights on the network interface cards, switches, and routers, checking the IP configuration, IP address settings, subnet mask, gateway, and DNS configuration. Testing the connectivity by pinging the local gateway, pinging the DNS server, and pinging or accessing external websites. Restarting the devices such as router, modem, switches, or your own client devices. Isolating the problem by testing visual areas such as testing the wired and then wireless network, testing the single device and then other multiple devices, checking the router or access point setting, including the DHCP setting, checking the Wi-Fi channel and the firmware. Using some command line tools such as ipconfig, ifconfig, ping, traceroute, or traceroute. So traceroute in Windows and traceroute in Linux. Objective 5.6, given a scenario, troubleshoot printer issues. So the issues may be with the print qualities, that is lines, fades, and grabbles on the prints, lines down the printed pages, in the inkjet, clogged nozzles, or dirty print head. These may be the causes. While in laser prints, scratch drum, toner, cartridge issue, or fuser problem. Faded prints may be due to low toner or ink level, may be due to fuser problem in laser or print head issue in inkjet. Economical print settings. Garbled print may be due to corrupt print jobs, incorrect print driver, connectivity issues such as loose cable, and printer memory problems. Speckling on printed pages, excess toner, ink buildup, or dirty rollers, damage drum in laser prints. Print quality such as echo, sizing, and orientation, double or echo images on the print may be due to fuser issue in laser, toner not properly fused, dirty or worn out rollers, driver settings such as incorrect paper type, incorrect page orientation, that is incorrect setting in the print dialog box, for example, landscape versus portrait, or application specific setting overrides. Paper handling and jams. Paper jams, most common printer problems, and this is due to incorrect paper loading, foreign objects inside the paper tray, worn rollers, or excessive dust. Paper not feeding due to empty tray, incorrect paper type, or worn out pickup rollers, or damage to the paper path. Multi-page misfeed, so multiple sheets pulled at once. Worn, it may be due to worn pickup rollers or static link and paper type. Tray not recognized, paper tray not fully inserted, or faulty sensor in the printer or tray itself. Mechanical and connectivity faults in printers, including the grinding noises, which indicates mechanical issues such as worn gears, broken parts, or foreign objects. Power off the printer immediately to prevent further damage to the device. Finishing issues such as staple jams, hole punch, problems with optional finishing units such as staplers or hole punchers, often specific to the module or incorrect setting. Connectivity, connectivity issues may include printer not detected by the computer, loose cables such as the USB or Ethernet cables, or incorrect Wi-Fi setting if the printer is wireless, may also be due to driver problem. Print queue and software problems. So multiple prints pending in queue, job stucks and not printing, such as these one, can be caused by a printer error, connectivity loss, or corrupt job. Frozen print queue unresponsive, cannot cancel or delete the job, requires manual intervention, often restarting the printer spooler service. Some general printer troubleshooting strategy include checking the physical basic of the printer such as power, cables, paper, and ink or toner. Clearing the printer queue, that is by deleting the all pending jobs, restarting everything including the printer, your computer and router when the printer is the network printer, running the diagnostics such as using the printer built-in self-test page or utility, updating and reinstalling the driver which is crucial for functionality and quality of the prints, checking the connectivity, pinging the printer when the printer is the network printer, or checking the physical connectivity if the printer is connected to the USB cable, consulting the manual or online resources, manufacturer support pages, and forms. So that's all for this course and this domain. We'll see the next course. Thank you. Bye.